Okay, hey everybody. Welcome to the fourth live stream of me hacking, well, not just me, but all of you guys, hacking the HTC Vive.
And trying to figure out VNC!
And we were a little bit ago trying to figure out VNC, that is true. So some of the things that we've been doing over the last couple times is we had been trying to, well, first of all, get access to the Watchman controller, be able to read the times coming off of that. Then, it worked. After a bunch of help from Ben and the rest of the guys over at Valve, I feel kind of embarrassed. It's barely reverse engineering when you get the help of the company who made it. And we've been trying to figure out the position of the lighthouses based on this position of the headset. And as somebody just asked about the factory config, much thanks to Ben. And HTC, is apparently HTC did keep a copy of my configuration. So I was able to actually get that copy of the configuration and put it back on the headset, and it tracks just fine. So it looks like it worked. And on top of that, I did actually get the new positions and normals of my headset up on the GitHub thing. So if you go to the GitHub, what is it? The GitHub Live Survive issue number 3. Let me make it a little bit bigger so you can see it. You can actually see that yes, Ben came through with the email to HTC, and HTC did have my configuration still there. So that's really good news. So if you want to get the points that we're operating with, you can totally get that. Let's see if I can get the normals. It's somewhere here. I also took the normals for my headset, which I found out is kind of important. I have my program totally did not work that well. It was telling me like lighthouses would be under the floor and all this other stuff until I started taking into consideration the normals. And what I did with the normals was, let me draw a little thing here. If I had a camera position that I was going to try to go to, and so say for whatever reason my algorithm thought the camera was down here, even though the sensor has a normal pointing up that way, because the camera is behind the normal of the sensor, I can now know, boop, that's not it. That's not a good tracking point, because there's no way for this lighthouse to be able to cast a ray onto this sensor and for the sensor to see it if the sensor's pointing the wrong way. So as soon as I did that, I was able to resolve much better the where I thought the lighthouses would be. So some of the things I really wanted to dig into this time were I wanted to find out, first of all, from you guys, if anyone in chat knows where to get a copy of the positions and normals from the Watchmen. So what that is would be the on these controllers right here. I want to know if anybody knows where to get a copy of the thing. I think I saw it online somewhere, but I just don't know where. But the thing that says where the location of all of these points are and their normals. And that'll come in really helpful, I think, because from my algorithm, if I just have the Vive and I'm trying to figure out the positions of all of the lighthouses based on only the Vive, it's kind of hard because there's about maybe a 2 or 3 decimeter area, easily 2 or 3 well, it's about 2 or 3 decimeters that I really can't figure out where exactly the lighthouse is within. So let me first bring up that program, and I'll run it. Make sure I can run it. I've not tried yet on this user account. Under Tools, Plain Test 2, make. Correct HMD points. So I'm just, I guess if you guys want to see this, how you guys can play along with this tool, I did post the files in the issue, so I'm going to go download them. So correct HMD points. The next one is HMD normals. I'm going to go download that. And that's downloaded. And what's the last one? Test 5. Was I actually already on test 5? No, all I have is test 4. Let's see, is that the last one I posted? I guess we'll use test 4.
Ta-da!
I have fixed your cursor.
How did you get it?
It's a totally different setting that was not highlighted. It changed. It definitely does not highlight only the things that you've changed. It was use local cursor. Use local cursor is false.
Okay, guys, so you guys know that? Use local cursor equals false, apparently is the thing.
In VNC.
Yeah, there may have been another option. I don't remember what flags I passed this. Let's see if I can. So this one I say X11 VNC, no X damage,
So
pointer mode, show
It's
cursor.
cut off there.
Oh, sorry.
Yeah.
So this is the command that I used on my client. For those of you who are watching this after the fact, what you missed was the fact that we spent the first 15 minutes of the live stream trying to figure out how to show the cursor on the actual live stream. So that was a little bit embarrassing.
So let's just bring attention to it.
Yeah, back to work now, though.
Let's remind everyone of all of our flaws.
Are you guys in chat, able to monitor, seeing what's happening? Brendan?
I am looking at the chat.
Okay. So I'm going to go change it from test 5. Test 5. Haha. I mistyped that. Test 4. Okay. Can't open two Lighthouse's test data. Did I really? Can't open two. Oh, test FOUR. Test FOUR.csv. What did I mistype?
Charles, do you mind if I shoot out the stream to the Hackerspace members?
You absolutely should cast the stream out to anybody you think of. Let's see. That looks like a reasonable answer. So what this program does right now, I guess I should go over kind of an overview of how I decided to tackle the problem, and let you guys know that the problem, this solution doesn't really work out as well as I thought it would, and I'll explain why I think that's the case, and we'll talk a little bit about some of the things that we can do to try to make it a little bit better. So I have, let me see if I can get this. Gotta have some way of holding this here. Is there anything rigid you can find for me? Hey, give me a board game box. Like Constantine kind of.
Sure you don't want to write on like an oscilloscope or...
I don't have any good oscilloscopes lit around or downstairs big.
Game of life.
So we will be explaining this Lighthouse thing on the Game of Life here. Okay. Anyway, so what I had set up was I had the system set up where I had the head mount display with all of its wonderful photodiodes on it, and I have two lighthouses. Now, for those of you, I know somebody said lighthouse question mark. Lighthouses are the funny black boxes that come with the Vive system that emit infrared out into the scene. So what they actually do is they'll sweep a laser this way on one axis, and they'll sweep it this way on the other axis, and it's creating a plane of a laser, like swooping down. But between those two, I can have an imaginary point that comes out from the lighthouse into a point on the point on the head mount display. I can have a magic one that comes out of this and goes through a point on the head mount display. So what I wanted to do is I want to find the lighthouses in a coordinate frame that starts in the center of the head mount display. So you can actually might be able to have a shot at seeing that. That's a little bit awkward, but our center, what we're considering our coordinate frame, is going to be where the head mount display is located, and we're going to figure out where the lighthouses are relative to that. So my first approach was to take these cameras and then move them everywhere in 3D space, just everywhere I could think of, and then orient them in all sorts of random directions until I found a direction that kind of worked. This is really terrible. This is really, really terrible. Because you have to search in 6 dimensions because there's 6 degrees of freedom. And that takes a while. It worked, but it took quite a while. And so that was terrible. So then the next thing I did was I decided to start using some linear algebra so I could try the camera in all these different locations and then use the magic of linear algebra to get the camera to point at the head mount display. And then I would go through each of the different photodiodes that were visible to the camera and figure out, well, how off would it be if the camera was right here? So that worked a lot better, but I can't seem to reliably get the position of the lighthouses all that accurate that reliably. So let's first start by me explaining what it was. Like how if I say lighthouse is here and I want to point it at the head mount display and have it oriented. So from the lighthouse's point of view, it's going to be pointed off into the middle of nowhere land. So first we have to get the lighthouse here to point at the head mount display. And the way that we actually do that is through the magic of some quaternions here. What I mean is, right now, if I'm a lighthouse, let's start on a new page here. If I'm a lighthouse, I'm pointed up by default. Like I'm just going to say this direction is plus z. See, plus z, terrible drawing there. What I'm going to try though is I have a head mount display down here, with all these little dots on it, and I want to be able to find out how would I have to rotate the lighthouse to get it to point over there. And what I can do is I can draw out an imaginary ray that's going in the direction that this thing thinks it sees a light, and I'm going to draw out an imaginary ray from where this lighthouse is to the point that it should be intersecting. And then what I can do is I can take the cross product of these two vectors, and that will give me an axis. And in this case, actually I guess that's out of the page. So it'll give me an axis to rotate about, which is out of the page. And what I can do is I can take, that's the cross product, cross product, and then I can find out how much it needs to rotate, find out this angle here by using the dot product. Now, by using these two things, I can now point the head mount display at point the lighthouse at the head mount display. So what I ended up getting is something where it would effectively show a bunch of dots for the head mount display and a bunch of dots where it thought they would be, but they would be oriented all wrong. And so I have to, and by the way, the point that I was pointing at is now dead on. But now I have to go rotate it a bunch more and rotate it around and try to get it so that where it's pointed and that axis is exactly where it would need to be pointed based on that location that it's currently at. And this worked actually relatively well and was relatively fast. And that, I guess I should run it and show you guys what some of this looks like. So at the end of the program, right here, I have the output. And so what this shows is the position that the head mount display was actually in and the position in image space that we think we were pointing at. So I say image space, I mean from the point of view of the camera. Calc. Let me just paste it in here. Oops. And I'm going to graph this. So I'm going to show you guys. So this is from what my thing thinks the best location is. And so let's pretend that's some of the points on a head mount display. And you can see the points actually kind of line up to what the head mount display really is. So if you look here, you can see based on this, it is getting, let's see if we can get a better view. It is getting some of the points on one of the sides of the head mount display. So that's what those are. And then, let me fix my axis a little bit here. 0.04? Okay. Then I can also show the other data range. So let's add new column here, x values, boom, y values, boom, oops, y values, boom. Okay. And so now we can see that where the camera, where the watch, where the lighthouse, from its point of view, again, the lighthouse has no way of seeing anything, but it does have a point of view. From its point of view, the red dots are where it thinks it sees the dots on the visor, and the blue dots are where they should be. So we can see here the lighthouse and the visor have kind of lined up, but really not that well. And there's this one point that's just off in the middle in nowhere land. And we can look at it from the other lighthouse's point of view as well. So right now I'm looking at the L lighthouse, which is the one that's closest to me, the one up there. I'm going to now look at the R lighthouse. Let's take a look at that one. Save, run. So now, from the right lighthouse's point of view, oh, why did I delete that? There we go. Let's do that again. And we're going to fix our axis so that we can actually see everything. So now this axis lines up extremely well. So I have a fairly high degree of confidence that it figured out where the lighthouse was pretty well. Now the only problem is that because the angle is so narrow, because from the lighthouse's point of view, the head mount display. So we have a lighthouse over here, and it's looking out into my living room floor, and I have a head mount display over here with some sensors on it. From this thing's point of view, that's a really long way away, and those are very, very tightly placed. So all of those dots right there are very, very tightly coupled. So if it's looking to target on that one and it thinks it's whizzing by like that, it's like, okay, that's pretty good. But this thing could be moving in or out by easily decimeters, and I would have no idea. So that's one place where this algorithm is definitely coming up short. But other than that, it seems like it's getting at least a rough estimate. So I don't know exactly how we're going to solve this yet, but I would imagine some of it might have to do with using the watchdog controllers here and here, just somewhere else, so that it can have a wider range in order to calibrate based on. The only problem is we don't know where these controllers are, so we would have to look at it from Lighthouse's point of view. And then by doing that, maybe we'll be able to resolve a little bit better, figure out exactly what's really going on there. I know I've been talking pretty much straight through. Has anybody in chat said anything?
Carson is asking a question that is currently up on.
Can't you just get the time between the sensors are hit by the sweep, since you know the sweep speed calculate angle? So that's what we are doing. We're actually figuring out, based on the sweep time, the sweep speed, from this lighthouse's point of view, what angle it's at for the head mount display right there. So some of the things that I really wanted to approach, I don't know if anybody keeps track of like my Twitter or anything, but my recent post to Twitter has exactly to do with this project. Let me go close the cap on this. Let's make sure you can see. Yeah, good. Okay. So if I visit Twitter,
Subclone asks if you're taking averages of the data.
Oh yes. So the Celbalone wanted to know if I was taking averages of all of the data, and the way I did it was I just ran for like 10 seconds and took the entire thing as an average. Just the whole thing, average it together, and that's where we're going to be considering our points. So I was able to resolve the angles pretty tightly. So the one thing I wanted to mention was this right here is part of my Voxatron, or sorry, Voxeltastic. Hold on, let's just visit that right now. cnlore.github.io/voxeltastic. Okay, so one of the problems that I ran into is I needed a way of visualizing in 3D space how likely it was that any one of that I might have the camera right. And so I have a level of confidence. If those dots do not line up with where I think the photodiodes are, if those rays don't line up, then I know the camera's not there. But maybe it's better in some places, maybe it's better in others. Maybe there's local minimums and local maximums. Maybe the global minimum and global maximum, or I guess all I really care about is global minimum error, is the same as all the local minimum errors, in which case we can do a lot of things to speed it up. Right now, all I'm doing is I'm searching through all the points until I find like, hey, this one looks really good. I'll just go use that one and then just go a little bit around there and search more. That might not be the best way to do it, but until now, I've never been able to really visualize that data. So this right here is the Wi-Fi, visualizing Wi-Fi video. So this area right here is in about a 0.3 by 0.3 by 0.18 meter space, the amount that Wi-Fi signal is up and down, and these nodes are static, and there was a whole video about that. Just check up on the Wi-Fi video if you've not seen that. This is some really cool stuff. Point is, since I made this video, JavaScript now has a file API, so I can load my own file into this to visualize. So I'm going to be trying to output a 3D file so I can take a look at the probabilities of how likely it is that the lighthouse is in any one location. So let's go do that right now. So part of CamFind here, I go through and I have a whole bunch of printfs. I guess I'm going to have to clean some of that up. Or do I? Nah, I don't. I don't have to do that. What I will do is I will make it so I have a first run. Oh, I could just do it on cycle number. And splits. Let me make sure that this actually works out to the right number of everything. So what I'm doing right now is I'm just going to try to make sure that when I'm searching the space, the area in which I want to see how likely it is that the lighthouse is in any given location, I'm printing out the number of points in that space I'm looking at, and I need to make sure that it is something with power of 2 edges. So Voxeltastic here, it can only display data if it's exactly power of 2 sizes. So if I have 423 pixels wide, there's no way it can display that data. But if I have 64 pixels wide, good to go. 128, probably good to go, maybe. The point is, it can't do non-power of 2. So we're going to have to make sure that we search a power of 2 space. So let's switch this to, I don't know, 32 pixels wide and see how that goes. So that's X, Y, and Z. Let us see if that works out correctly. Okay, so it thinks it had 139,000 something. That is not a power of 2. Let's see here. What if I get rid of the less than or equal to? 131072. That is a power of 2. Let's see, make sure that that's right. So that would be, I think, 64 by 64 by 32. 131072. So we have a power of 2 points that we can investigate. So what I'm going to do is I'm going to open a file. File star f equals, ooh, actually better yet. If cycle equals 0, f equals f open, raw data lighthouse dot dat, I guess. Voxeltastic only takes in straight raw files. It can actually do red, green, blue if like you have 4 things, or it'll just do a heat map if you only have 1. So right now we're just visualizing one lighthouse's position in 3D space. So let's see what that looks like. So if cycle is 0, f open, all that jazz. Then once for every single dot, we're going to go display it. We're going to figure out what it is at that space. So I'm going to say, so we don't need that cells thing anymore. For this particular location, I have the FT, which is the quality. If cycle 0, you know what I don't have is, I don't know what the range on this really should be. Let's make it so that if the RMS error is greater than 1, then I say that can't possibly be it. So if it's greater than 1, sk equals 1. Otherwise, it's going to be between 0 and 1. And so I can say fprintf f %c, and I can print in okay, so what I'm going to do here is I'm going to take the amount of error. So run opti is the part of the algorithm that orients and reorients the lighthouse to try to figure out from this particular point of view what is the best orientation, and then it tells us how good a match is that from that particular position. And it'll tell you, okay, so from this particular position, we have a really, really good match. Or from this particular position, I just can't get it to line up. It looks terrible. It just looks terrible. So that's what we're going to be looking at. From a given position, does run opti say good or bad? And so I want to just see what that heat map looks like. I'm going to go here, printf, f cells, %c, dump the data. If cycle equals 0, f close f. Done. Let's try it and see if this thing works. I have an error. Okay, forgot to include std int.h. Okay, oh, it's sig faulted. That's a bummer. gdb run 35. Did that not work? bt. Oh, 85. Printf f cell. Why is that not good? Nil. Why is that nil? Oh, right binary. Okay. Boom! Cool. Let's see if it made the file. It did. Hex dump -c raw lighthouse data less. Okay, let's take a look at this. Looks like most areas are FF. Oh, you know what? We should probably invert that so that the areas that have a whole bunch of error would be very low on the heat map. So I'm going to say 1.0 minus SK. All of that times 255. Boom! Got something. Okay. Let's see here. Let's try loading it and see what it says. So the X size is, what do we say? It was 64 by 64 by 32, I think. No, I don't want to flip. And no, it's not an RGBA map. So this is the very first time I will have seen this data. I have no idea what it looks like other than some random printfs I've done here and there. I've had no way of visualizing it. Let's see. Oops, not voxel-tastic. Live survive. Tools. Plain test. Raw Lighthouse data. Hello! Look at that. That is interesting. I don't quite know where the axes are on this, but that's interesting that it starts at a point which looks like about 0, 0. Actually, it is 0, 0. And it says everything from anywhere near there is good. Huh. Maybe we need to tighten that up some. Let's make it so times 10. So now it'll be more difficult for it to look good. Oh, hello. Okay, so what we're seeing here is in 3D space a representation for all of the possible places that that lighthouse camera should be, and that is not the shape I would have expected.
Looks like a human brain.
Yeah, that is a little bit funny that Brendan just said it looks like a human brain. I would not have expected. I would have expected that the lighthouse would have had a harder time determining depth away from the target, and an easier time determining position. Let me. I'm going to draw a dot right at 0, 0, so I can tell where the origin would be. Let's see. How would I do that? That would be. Okay, it'd be in here. If what am I looking at? If dz and dx is greater than negative 0.01, x is less than 0.01. And I guess those parentheses aren't needed. dy is greater than negatives 0.1, and dy is less than 0.1. Then we're going to print 255, so we can at least have an origin. Oh.
Answering the lighthouse question.
Yeah.
Okay.
Oh, so you guys are actually helping out with the answers. Yeah. Okay, so this thing here is a cloud of I guess points of where the camera could be relative to the lighthouse. So I guess I'm gonna cut into that a little bit more to see. Okay, so these are all approximate areas. Let's make it even harder. So I'm gonna make it 100. So it would have to be a very, very close match for it to even appear. Did you guys see this yet?
Yeah.
How crazy is that? It looks weird. Let's run it with a more constrictive view. So now it should be a much smaller area around it.
I'm answering orange.
Oh. Well, that's annoying. I guess it's not visible at all from that. Let's try that again. Let's do 20.
I mean, the lighthouses are what make this room scale versus the Oculus.
Aha! Okay, so this is really cool. It looks like as we start to really tighten down, it is much it's really getting clumped around a specific area very well. I wonder if there's some sort of numerical method we could use in order to, say, take this data and then fit it with like a Gaussian curve or something to figure out where it is best. Because right now, I'm just iterating through every point trying to find the best one. Let's keep pushing this tighter and tighter and seeing what this looks like. Are you guys in chat having fun watching me like do this, or like?
Several people are very interested.
Okay, so this is not boring to people.
You have an influx of people that don't actually understand what's going on. If you
Okay, then tell you what, guys, I will, in about 2 or 3 minutes, I will go do a review over how the HTC Vive does the thing it does. And then if you guys don't want to watch that, you can go like to the bathroom or something. So this is looking really promising because from my point of view, that's I was expecting this to look very different. So there's clearly some jitter, but for the most part, the expectation for where the camera is pretty good. Maybe this might actually be sufficient to go do the problem with. Let me just view this from an absolute point of view. 255, 0. Oh, never mind. I had it a little bit unrestricted. So it still is not really that sure. Okay, so as we tighten that up, let's try 50. Okay, that looks pretty good. For those of you who didn't notice, I changed the levels on the side. Originally it was a very restrictive point of view. So let's try keeping on tightening this up and seeing what we get.
Toby asks if you're at the stage where you can look at 2 beacons and see the spatial visualization or not.
I don't understand.
How you're seeing 1 beacon in the viz right now. How would that look with 2? Are you at that point? Can you make that happen?
How would I look at 2 beacons?
That's a lighthouse.
Oh, looking at where both beacons are.
Yes.
Right.
That's a really good idea. Let's do that. So this is 1 beacon. So unfortunately, I have it loaded as L or R, so it's in 2 different files, and I'd have to merge those 2 together to. How would I do that? Tell you what, I could just write a program. I could just do it once for the R and do it once for the L. So I'm going to go loosen this up a little bit so it's not quite as restrictive. Okay, so this is, oh, you know what? Trying to just find a good level to visualize this at. Oh, there we go. That looks pretty good. So there's the HMD in the middle, and there's 1 lighthouse up there. And now let's copy that file. CP raw lighthouse data, and that's for the R lighthouse. .dat. I'm going to do it again for the L lighthouse. So R lighthouse over there, L lighthouse over here, I think. Also, I just realized if we move this window over here, then when I look at the window, I'll be looking at the people. Okay. Hopefully that'll be a little bit less disconcerting to everybody. Does that bunk you when I keep looking not at you and at you? Okay. So L lighthouse. Let's run this again for the L lighthouse. Let's see what that data looks like. Oh, it can't find the L lighthouse. Let's make it much less restrictive.
I'm answering days.
Yeah, I can't answer that.
Oh, that's interesting. The other lighthouse, it has no idea where it is. That's not good. I was expecting, so, okay, we'll look at these two lighthouses in the same data set. Let's do that right now. Again, I'd like to remind everybody out there, if you guys know where to find the list of all the points on a Watchman controller and all the normals of where all the points are on the Watchman controller, so points and normals in space of the Watchman, please post that to the issue on GitHub and in chat telling us that you have it, because I don't know where to find it and I know I've seen it before and I don't really want to go look for it in the middle of a live stream. So right now we have our lighthouse and L lighthouse data, and I'm going to go write a program real quick to just that data together.
Michael, you want to tell Royal what a lighthouse is again?
That's what oh.
Well, Microhex sort of.
Yeah.
Yeah, and Paul. Looks like everyone kind of jumped.
Mm-hmm.
Bonus.
As everyone catches on, they're kind of filling in the gaps for everyone else.
I just wanted to let you, Michael, know that if you think that what you're working on is something that would be interest to these people, and if they want to like hop in, comment on it or anything, I think I'm going to be like I'm only going to work in bits like spurts like this. So if you want to think about something you'd want to talk about on the live stream, think about it. I'm sure in another hour or something, be ready to go. And David, for you guys, he's out of frame right now. David Chapman, he is also here. So he's the guy who is working on Matrix. That's Dave waving. That's inverse phase right there, and that's Mike over on the side.
Hiding.
And
Hiding in the back.
yeah, and they will be talking about various Vive-related things later on in this broadcast. Ooh, let me fix the camera. There we go. And again, thanks to Unity for buying the Vive for me. So right now I'm reading the left lighthouse data, the right lighthouse data, and I'm going to be dumping it into a dual lighthouse data so I can visualize it. So this reads the right, this reads the left. For I equals 0, I is less than 131, O 72, I plus plus. I'm going to be dumping into the output file, O, the following data, RDI, LDI, and actually maybe it should just be 255, 255, 0. Oh no, that's not right. Int R equals RDI, and LR equals LDI. int alpha equals how would I do that? RR is greater than LR? If so, RR, otherwise LR. So alpha picks the most important one. If RR is greater than 1, R equals 10. No, let's not do that.
This isn't going to change the actual rendering load, but it's going to change the CPU load for doing a lot of the calculations and stuff.
Yes. Yes. No, I can't do that actually. It'd be okay, fine. So RD, LD, and alpha. Let's just try that. Oh, what did I do wrong? What did I do wrong? Oh, RR. What?
Yeah, or just banning spanners.
Yeah. Just
I'm trying to catch up with them. There we go.
yeah, I can't do it.
Sorry, I got
Nor would I know how.
there. If you point to people, there's a dot 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 on it, right? And if you're a moderator, there's.
Let's take a look at what this data looks like. So that's the probability for the derpy light. Now we're going to use an RGBA map, and we'll take a look at the combiner's dual lighthouse data. Okay, so that's a little interesting. I wonder why the one lighthouse is completely terrible and very poorly grouped, and the other lighthouse is so wonderful and very tightly grouped. That actually looks about right too, because I think it was from about this point of view, and that would mean that both lighthouses are probably at about the same height. Okay.
So
Let's That's really troubling though. So the red one tightly grouped, that means that we're pretty sure that that's where the camera is. And each one of these cells, let's see how big each one of these blocks represents. Each one of these blocks represents 5. Yeah, it's 5 divided by 64 decimeters, or sorry, 64 divisions. That's 7.8 centimeters. So the grouping on this one would have to be about 1. Let's count them. 1, 2, 3, 4, 5, 6. So about 6, 7.8 centimeter blocks.
Someone asks if maybe one of the sensors is hitting a more densely populated area of sensors and the other one is not.
well, the headset setting's flat straight up in the middle, so they should
Yeah,
be hitting it about
I think they were hitting about the same number of sensors too. I had oriented it so that the lighthouse was directly between the two. So that means it's 4.6, even on the tight one, it's still 4.6 decimeters.
Somebody's saying that you use
Oh, wait,
different
yeah.
restrictions to refine the points on each side.
No, I'm using exactly the same restrictions. It's exactly the same code checking each side. No, there's nothing reflective on the floor.
Let me go take a look over here, see if there's anything in the way.
That's really odd. I guess we could just take more data. We're gonna have to turn off the lights though for that, because you guys check it out. I'm using drop lights to light it up. Tungsten lights look really good on film, but tungsten lights, I guess, could potentially mess up the Vive's sensors. I don't know.
Yeah, I'd say probably.
Okay, I guess it's time that I go and I do my little spiel again on how the Vive's the Vive. Whoops! Oh, I can just do that. That's a lot more convenient. How the Vive works, I guess. At least my perspective on it. Am I here? Good. Can you guys hear me? Is this clear? Levels good? Levels look good. I guess I'll just start talking. Okay. So I guess you can't really see it, but it's fine. So the HTC Vive, this thing right here, is, as far as I'm concerned, the complete future of everything VR, and that's because of room scale. So a bunch of different people have kind of gone in a direction to try to make room scale VR, and people are doing with cameras and other stuff. But there's a technology that I had never even thought of, and I've done computer vision things before, and I just never saw it. I don't know, I guess I was living under a rock. And it's this idea of Lighthouse technology. And so I've been saying Lighthouse, 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 Lighthouse. And a lighthouse is one of these little boxes. So like this thing right up here, that is a lighthouse. You can kind of see it flashing a little bit and showing the, you can see the infrared light and then 2 scanners. And the way it works is by taking just flooding the scene with light, just like a camera flash, and that tells all of the little dimples on these guys, all of these little sensors on this, exactly like, hey, synchronize, know what time it is right now. And then what it does is it takes a laser and it sweeps the laser across, and it hits these one by one, and it sweeps it across the entire scene. And so the time between that flash and when it actually sweeps and hits the different sensors, that's how it knows exactly where in this dimension it is relative to the lighthouse. It does it again for this dimension, hitting all of the sensors all the way down. And the cool thing is it does it from 2 lighthouses. So it still uses IMUs like many of the other systems, like the 6 Sense and the controllers and the PS3 and 4 and all that, to tell like, oh, I'm moving really quick in this way. So it doesn't have to wait on the data from the lighthouses to figure out where it is. I guess it does know where it is, but from frame to frame, if I move it, it doesn't need to wait on the lighthouses to tell it that I moved a little bit. It can tell that really immediately. But the lighthouses give you the ability to track basically an unlimited number of points in a 3D space, and track them very, very precisely and absolutely. And that is something that is kind of like the holy grail of tracking, and that's why I think the HTC Vive is like completely the future of how this works. And so again, the idea is you sweep past, and so what we're trying to do in this project is, I guess Live Survive is a much larger scale project. It's one that it's going to have impact as far as the goal would be to make it so you can just straight up write games in Live Survive for in a very, very minimal framework. So an HTC Vive, something that says clearly requires a VR capable computer right there. I think that's a little bit ridiculous, and I'm going to see if I can get it to run on this, my Gen 2 Core i5 really, really terrible book that has integrated Intel graphics. So I hope that was a good overview. If you guys have any questions, feel free to ask right now.
So somebody, I was curious about something actually.
So come over here and talk to the mic.
So I've been working with the Vive since early summer. Hi, I'm Mike, and I was curious that I've seen that the Vive can both locate where it is currently, but it also has a bit of a predictive aspect where it can tell where it should be as well. Is your library going to handle that, or is it just going to leave that be for now?
So that's something that we're working with Dave on. David Chapman is also in the back over here, and we're working with him on the on some more of the details about the Kalman filter, and it'll be using motion, as far as I understand, to tell both, like, based on my current motion, I expect it this time, even if I haven't received any sensor updates, I expect to be here. Is that correct?
Yeah, that's correct. So a common filter is a linear prediction model. So one term is the prediction term, right? Your best estimate of state at the next time step, given information from only the previous timestamp. And then there's another term which is your best estimate of current state given only current information, right? So the question is, how much do you weight new information versus your prediction of motion? So it depending on those weightings, right? Depending on. Oh, sorry. Yeah. Okay. So I was just saying.
Over here. Go over there. Where the mic is. Okay.
Is this the right place to be?
No, on the other
No?
side. Other side of mic.
Other side. Okay.
Oh,
Here, I'll
We're
give you,
figuring this
I'll give
out.
you this to sit on.
We are figuring this out. So I was just mentioning that common filters are a predictive filter. So there are really two terms. One is the best estimate of state at the current timestamp given only information from the previous timestamp. So that best estimate is entirely a prediction, and that prediction would include your current position, your velocity, acceleration, and also your acceleration in direction as well. So then the other term would be your best estimate of position, or partial estimate of position, given only information that you see at the current point in time. So really, the question is, how much do you weight those two terms? And depending on your measurement model, you could have an uncertainty model for your measurements. And depending on what those weights are, just because the accuracy or the precision of a sensor is X doesn't mean we can't change the number to make it weight the prediction part more, or weight the measurements more.
okay. I just found that really interesting that the Kalman filter came up now of all times. I actually learned about these, I don't even know how long ago, when I was in the Navy. I worked on the IMU, or the gyros, for the ship itself, and that was one of the systems that I was working on, and part of that was learning how a Kalman filter worked and how they calibrated. So it was always interesting to learn about that, and then suddenly, almost 10 years down the road, have this come back up.
Yeah, and
Sorry, real quick.
yeah. Sorry. Question?
Yeah, I gotta say something. Sorry.
So, while they're off to the side, briefly, just a Kalman filter is actually used in a lot of different places. I was on a cruiser in the U.S. Navy, and our gyros for the ship actually used a Kalman filter to help us with dead reckoning and position.
Someone in the chat mentioned UAVs and flight control as an exciting application. So
It's also used in other applications such as UAVs, flight control, or any place where you could have data coming in, or you could be reduced to a dead reckoning state due to either a loss of data or unreliable data coming in.
Let's see. Has anybody else in chat really said much that we should be addressing right now?
I just pointed out the thing that someone said.
Okay.
Okay.
Anybody else from chat want to mention anything or have any other questions until we? I guess we got to at some point look at the next thing on the agenda for tonight. Wow. Matthew Jones asks, then why would it affect one of them? Only one of them. I don't understand. They're talking about they're talking about the noise patterns. Why it would affect only one of the lighthouses. I don't know. I think we'll talk more about the lighthouses a little bit later. If you guys have questions specific to Kalman filters and like what we're talking about right now.
So, Nathan, I saw that you were asking if we could feed accelerometers or data from the inertial directly from the accelerometers. You can, but by applying the Kalman filter, you're able to smooth it out and get a more accurate picture of what's actually happening than just taking inertial data right off and saying, okay, well, we must be going exactly that far. Using the Kalman filter, you can help smooth that out and control what you're seeing instead of just trying to shoot raw data at it and see what happens.
Anything else, or does the 5 depend more on the GPU? Okay, so no, we're off. They're asking different questions now.
I'm
Yeah,
answering
that-
that.
Okay.
Why is depth better estimated than angular resolution? Was an earlier question.
Oh, are you? So I think it's actually we should probably move back to this because people are asking about that.
Sounds good.
So you guys can sit back down
Yeah.
or wherever you want to work.
Let Charles move back to the visualization science for a while.
Yes. So I did want to at least say I have no idea why it's so good at measuring depth estimation and so bad at measuring the where it is. I don't know. If anybody has any ideas, that would be super cool, because I did not know the error bounds looked like this. Sweeps are... Okay, so I guess I should also mention the sweeps and the way that works. Is that what goes on is Lighthouse number 1 up there, sweeps, flashes, sweeps, flashes, sweeps. Then Lighthouse 2, flashes, sweeps, flashes, sweeps.
Where does creeps come in?
You've been scolded for being too loud.
Oh, I'm sorry. I'll be more careful with that in the future.
No, you won't.
I will. I'm learning.
Sweeps, the bleeps, and the creeps. Can you make the noises, please?
I don't know what are sweeps, creeps, and bleeps.
Spaceballs.
Oh, sorry.
You know, the bleeps.
Shame on you.
I don't know.
And the creeps.
Yeah, I would have expected depth to be way, way less accurate. Like, super less accurate. But that's not what reality is showing us right now. Huh. And right now, this is solely looking at, for each one of these red and green blobs, it's only looking, oh hey, it's kind of Christmas themed. It's only looking at the, is the depth right? That's a really good question. Let's find out if the depth is right. I'm going to go back to plain test 2, camfind.c. Let's let it run, give me a solution. Oh, you know what? We need to collect more data. So actually, this is a really good time. What I'm going to do is I'm going to set up this system exactly as I would set it up to do the calibration. And I'll record some data, and I'll post this data into the issue, and then we'll use that data collected from this time to check it, and we'll get out a tape measure and measure the actual positions of the lighthouses. So I have a lighthouse. I'm going to position it, I don't know, about right here on the floor, so you can see that. You can kind of see that. Okay, so my head mount display is right here on the floor. I'm positioning it so that a bunch of sensors can be seen from the point of view of both lighthouses. I don't know, do you think I should make it so that it's pointing this way? Or...
Somebody is saying that it's not from the lighthouse to the headset, it's measuring the depth between the two lighthouses.
No, it is not measuring anything between the two lighthouses.
Are you gonna be disturbed if I make caramel popcorn?
Do we want to spoil the... sure, whatever. Make caramel popcorn. So this data is entirely to do with the headset. Data coming from just the headset, not the two lighthouses. Unless if somebody else knows, is there a photo sensor inside the lighthouses? Because if there's a photo sensor inside the lighthouses, by gosh, now we have another absolute data point or reference so we can find out some absolute angles.
The lighthouses do actually communicate and synchronize with each other, so they have to be visually in sync with each other.
I think that I don't know how they do it exactly, but
I don't know.
I don't know. So if anybody else online knows if there's a way for me to get the data from like the lighthouse, oh, I see the flashes coming from this other lighthouse, that would be cool.
Yeah, I know that they do synchronize in some manner, but
Yes.
I'm not sure the method.
I don't know how either.
Method or protocol or anything. I don't know how it works. I just know it happens.
Okay.
Tim mentions how the Oculus works. He says it illuminates IR LEDs on the headset in sequence, in sync with IR cameras.
Yes.
So,
Which is totally not the way I would want to do it.
Yeah.
Okay, I'm going to orient it this way, just trying it. I have it sitting on the floor. It is right now oriented with the camera pointing towards, I think that's L camera.
Also,
Or sorry, L Lighthouse.
just curious, what channels do you have your lighthouses set?
I have my lighthouses set to B, and channels B and C.
Okay. Just making sure, because A is only supposed to be used for a wired operation.
Yes. Yeah, one of the things Ben suggested we did before was to use one lighthouse in mode A. And I did that, and I was able to get the data, but I think it's much more interesting to just operate off of 2 lighthouses. So at any rate, let's get some of this sweet, sweet data. I have a thing that I called Data Recorder. So I'm going to go run that. Actually, let me make sure. Where's the... Oh, you know what? I'm going to just turn off for right now the Watchman. And so we won't have Watchman data for this. So I'm going to run Data Recorder pipe T live stream test 1 with HMD in center.csv.
Somebody was saying, why don't you try hooking up to them using the USB cable for updating their firmware, just to see what you can pull out of them?
Somebody suggests hooking up to the USB cable. I mean, I could, but I tell you what, if you go buy an HTC Vive system and you hook it up and you get some awesome data, go share that data with me. I'm very, very tight on time. Oops. Okay, let's see. Is it doing it? And I press O to send. Oh, okay. So that's another thing. Sometimes the HMD just stops sending data, and I'm not sure why. It will give me the IMU data, but it will not give me the Lighthouse data.
just pick something else and then
Testing. So that's mic 1. Let's switch to mic 2. C media. Test. Oh, hey, good. We're moving again. Okay. So sometimes, for some reason, the head mount display just stops giving me light data, and I don't know why. So we're still trying to figure that one out. But if I plug it in, and I wait, and I run the program, and then I say "oh," then it should still not giving me data. Let's try that again. We might have to restart the head mount display. Also, the Watchman is on. Let me go turn that one off. Let's try again. Plug it in. I wait. I run it. Press O. It's supposed to send the magic to make it start sending me some data. It's not.
Back road, I can see the green LED.
That's really odd.
Green LED's on, so the HMD's working.
Yeah, and both the lighthouses are on. Why is it not working now? Sometimes if I just poke at it for a while, it just starts working.
He thinks your audio is quieter.
Is my audio really? Okay.
Not necessarily bad, it's just quieter.
Well, no, it's best to just max it out and then people turn it down on their end. Otherwise, when I yell, it'll be terrible. Test. Test.
Okay.
Can you hear me now? Oh, hey, that actually looks pretty good. I guess I don't need to yell.
Please don't.
Okay, you guys should probably calibrate it to this. And it's not working. Let's try just giving the head mount display a full power down. Okay.
There's a ton of background static noise now.
Bacon.
It's bacon.
Yeah, there's bacon cooking in the behind there. That's not static.
Do you smell what the atom is cooking? No, you don't, but you can hear it.
What?
I'm gonna just try rebooting the lighthouses here.
That's bacon.
That's no moon.
Bacon interference.
Beacon bacon.
Bacon at 10:30 at night.
Yeah, I'm hoping some of you guys end up getting a Vive to start, troubleshooting this with me to help figure out, like, okay, why is it sometimes being a little bit wacky with the dots? Okay, both lighthouses are green. Oh, give me data. Oh, give me data.
So, Charles, I have a question.
Uh-huh.
If I were to utilize the Vive in a normal capacity inside of Unity,
Uh-huh.
would I be able to also capture data from this at the same time?
No, they're exclusive, unfortunately.
That would actually have been amazing for me.
Mike wanted to know if it would have been possible to collect data from the Vive at the same time as the Steam interface, and I don't think that's possible. Sometimes it seems like if I...
What is happening over there?
John, we're reverse engineering the Vive to run on lesser hardware.
John wanted to know if we are making a virtual waifu.
No, we are not making a virtual waifu. I'm pretty sure a virtual waifu will not run on this laptop. Mostly because if it was, I think it would commit suicide because the laptop's so bad.
I saw a thing the other day. They're trying to sell a virtual waifu in a capsule in Japan now, and it sits on your desk like Alexa, but it's a VR girl.
Right.
Okay, head mount display is off. Plugging in USB.
I think I face palmed so hard my hand touched the back of my skull.
Running. Oh, got it! I don't know why, it just magically works now. Yay! Data! Yay! There's a thing running in the background. Okay.
Begging you to close the curtains
Close curtains? Why? What?
because the windows can act as mirrors.
Okay. Let me, F. I hope we don't have to go do that all over again.
Yes.
Okay, we're now collecting data off of these two, the two lighthouses. I'm sorry about the loud thing in the other room that's currently making popcorn. Actually, wait. Oh, good. Now it's a little bit quieter on your guys' end. So I'm collecting the data. I'm going to run it for another couple seconds, and then we're going to stop. I just want to get a lot of data points so it averages out fairly nicely. Hey, you know what? It's probably best if you guys watch the first video. Anybody who's new to this, the summary video between the two others. Brendan, can you post the link to my summary video, the 20-minute one?
Yeah, let me look for it.
Okay. So I think that's probably enough stuff. Hey, if you guys, somebody wants to go do a FAQ on the GitHub site, if you want, you can just do a pull request on my readme.md file.
Somebody was asking if the second lighthouse right now will improve your position estimates, or are they independent of each other?
Right now, the two lighthouses are completely independent. The goal is, as soon as we get this thing off the ground, that's when we'll use them in like coordination with each other in order to figure out better where we are. Trying to get this lined up better here. Okay. And this, there we go. Don't worry, you guys will see the popcorn when it's done, but you won't be able to taste it. Live stream with HMD. So that's a 3 megabyte file, so that's pretty good. Zip 9R, live stream, .zip, live stream, that, deflated, issues, determine location of lighthouses. This is the HMD static in middle of the room. Okay. Now let's go upload that.
I do have a line as well.
Oh hey, people are already commenting. How cool is that? Yes guys, please participate in the issues on github.com/cnlore/libsurvive.
Or libsurvive if you pronounce
Or
it.
libsurvive if you pronounce them libraries.
Libraries.
Call me when the guys from Vive make VR contacts. This looks like too much of a hassle.
Okay, I just published the copy of the test data, so any of you guys who want to play along, you can just go download this from issue number 3 on Live Survive. Okay, and so now I'm going to go into Tools, CD Plain Test 2, Copy, ... Live Stream Tests, all that jazz, / camfind.c, and we will open this file instead. Okay. Where is that? That's somewhere here.
Vive doesn't use any sort of like moving calibration like that.
Not that I know of.
No, you can start it up setting and it's fine.
I'm going to run camfind for L.
How about we hack Wiimotes instead to use with Google Cardboard?
Okay, so this is actually calibrating pretty well. What these settings here show me is that every single one of the photodiodes on this one from the lighthouse's point of view is actually calibrating to under a millimeter of accuracy. And this is the first time I've actually taken any data where that's the case. I'll feel like a complete idiot if it's because that stupid window there was reflecting the beams and I was getting false
I
data.
would not doubt that.
That would be so dumb. That would also mean that we should probably be using something like Ransack that can just ignore data points that are just outside of the mean.
You'd just be doing that anyway?
You know what? That's effort. I don't really have time to put in that kind of on. Can't really do that. So this is doing well. Let's go take this data. Raw lighthouse.dat. Combiner. This one is L lighthouse.dat. Let's run it again with R. Okay, so from the other one's point of view, the one on that side, that's actually a lot worse. That says 2 of the sensors are 2 millimeters out, and yeah, it's not very good. So I guess we'll just test that one anyway. So let's take a look at this data now. By the way, people keep posting articles in the issues. Please post code, post patches. There was a little funny thing GCC did with experimental versions where you have to set an environment variable that says, I promise to include patches for all bug reports. About ready to enforce that. So like, don't just post a link to something, actually like post the discussion from it. Ooh, that's interesting. Huh. That's actually worse. I would not have expected that to be worse. Why is that worse?
It's kind of exploding.
I mean, I'm now like looking over a very large range, but it shouldn't be this bad. I mean, it's geometrically correct, but that's still really depressing. Okay, so one of the things people wanted was they wanted to know if this was actually correct or not. So let's see. For the R lighthouse, it says it's 2.973. So let's just say 3 meters, and let's check from the L lighthouse's point of view. From the L lighthouse's point of view, it says 3.6 meters. So let's check and see if that matches reality. Adam, can you get a tape measure?
Yes, hang on.
Popcorn.
Should have been one right over here. Here.
Mike or Adam or not Adam, Dave, can you help me with this?
Yeah, sure. Is that a metric tape measure?
It is.
Very good.
I do choose my units based on the project. If I deal more with speed of light, I do more things in the imperial. If I do more things in like this, it's metric. So go to the nose on the. Actually, that's probably fine. So this says 293 centimeters. Okay, so 2.93 meters. Let's check to this one.
Which lighthouse is that?
That would be, I think that's Lighthouse. Can you bow it less? Okay. That would be Lighthouse 2, which I think is R. And this one says 3.6 meters, about 3.65 meters. So, oh hey, wait, actually, let's measure that one again. Yeah. Okay, actually, no, I'm wrong. It's 3.65. So, okay, so that's pretty close. So 3.65, 3.69. And this one was 290, a little, almost 300, so 2.9. So this one is off by only 5 centimeters. This one up here. That is L, correct? Yes, L. That's right. So that's off by 5 centimeters, and then the other one is off by, I forgot, what was the number again? 2.9.
2.93 according, or 5?
2.95?
2.93.
Okay, whatever. It's only off by like 2 centimeters. So I think we're figuring out the locations of the lighthouses pretty well right now. Not locations, just right now all I'm measuring is distances from the lighthouse to the headset right there. So I'm going to go with that's surprisingly good. Maybe we really can get away with this without doing a lot more work. Although I don't understand why the clouds are so terrible. Like, that's just awful. Why is this data so bad? I mean, yes, it can approximate distance great, but good grief. Okay, tell you what I guess I'll do. Let's try, I've been curious about this. I wanna try it again, except from instead of having the HMD oriented this way, I want to have it oriented in plane with the lighthouses. So I think that would be affecting X primarily. Yeah. So right now it's mostly affecting Y. So the Y, this position. I want to switch it so it'll be this way.
He was playing with a threshold value earlier to tell how close it had to be, but
Got at least 2 recommendations to just swap the lighthouses to make sure it's not.
a lot of people have been saying, swap the lighthouses, swap the lighthouses.
Why?
I
I don't want to swap lighthouses. It's a lot of work. What would
They
that
want to make
prove?
sure that there's not a physical difference in the way your lighthouses are operating.
Why would there be? What's just that the data's bad?
The idea is basically that if the factors for the difference in data are external, if you swap the lighthouses, then you'll get the same data. Whereas if the difference is in the lighthouses themselves, the data points will switch.
Could it also?
That's a lot of work.
Yeah. Would it be less work if we were to just move the VR headset closer to one lighthouse?
Yeah, we could just do that. Actually, that's a pretty good idea. We could just point it right at one. I'll just do another one real quick. Pipe T.
But it could be that the one that's worse is the one where it's closer
To
headset
x-axis.csv.
position relative to the lighthouse. That's the accuracy.
Okay. Oh, why did I do that? That was I need to get it oriented first, and then.
How about you do that and let me orient it?
Yeah, you do that, and then I won't dumb again.
Also, Charles, is
Yes?
there
Tell me
some
what you want.
tunable threshold in your model that you can try adjusting to see whether that would give you a larger or smaller cloud?
If you wanna.
Do you just want to point it at that?
Oh no, I was gonna have it sitting. No, doing it the other way. So.
Someone also suggests upside down as I think that will get you less data. But
Okay.
Yeah, I'm not. I don't think I want to do an upside down thing.
I don't think that's going to work too well.
Okay. Yeah, I don't think that'll work well either. But let's find out. So now it's pointed this way. Okay, let's just let this data run for a little bit. So right now, the reason I think this won't work as well is because the things are grouped so tightly. It's going to have a hard time resolving any kind of meaningful distance out of it. Do you want to ask, Dave?
You probably shouldn't stop right in front of it while it's taking
Oh,
data.
that's a good
I
point.
didn't think of that. Well, anyway, I just had a question for you, Charles. Whether or not there was some tunable threshold that could be adjusted that might affect the size of the cloud, something saying that it has to be within some sort of error tolerance or something like that, or whether that's adjustable, or if there's some confidence that it needs to have anything
I think-
of that confident. Yeah.
I think a lot. I do have a lot of stuff going on with the algorithm that finds the right orientation, and there's a lot of heuristics that go on with that. So it's entirely possible that that algorithm could be improved significantly to be more reliable. That maybe there's just something about this data that's making it not resolve well. But I don't know where I would search for that.
Because I mean, you're not just returning a single point.
No, I'm.
Because there's a whole cloud. that
Yes,
you're
I'm returning a whole cloud. Adam, are you done with the?
Done with the noise.
Okay, I'm switching the microphone back into slightly louder mode. Okay. I'm gonna also update the.
Can you easily put axes on the voxel-tastic blocks?
Um,
And
Can I put axes on it? Yeah, I could put axes on it.
someone else suggests to extend D at like use height, like on just on the chair or somewhere closer to where you would be actually using it.
Well, it has to be able to track there as well because to calibrate
yeah.
the floor height.
There is a calibration where you place it on the floor. I know. There's just also Toby asks what the points at the top of the GUI are, and is that skewing the average?
Tops of the GUI. Oh, okay. So the points at the top of the GUI. I guess I can bring that back up. What that's about is if I don't get data from both lighthouses, or sorry, no, if I don't get data from both X and Y. Oh, great. Now it's not giving me data, so I can't show you. But
It went into sleep mode. It looks like it's red.
oh, hold on, I can wake it up. Or not. It does not want to wake up.
Off now. Oh, there it goes. It's
It says it's green, but is it really waking up or is it just lying to me?
trying. Struggling
Is
with
it
all
trying or lying?
Yeah, I don't know. I'll show you guys that in a minute. Let me just try to run this right now. I'm gonna run with this new data.
Someone else mentioned, while we're asking for features in voxel-tastic, can you maybe make a note on the voxel plot of the size of each block so you can have a scale
It
reference?
died again.
I'm not gonna add that to Voxeltastic, though.
Wow.
Voxeltastic accepts pull requests. So if you want to go add that, you can go add that, and I'll go say okay.
Wait, so
It's
the
unhappy.
voxels are coded. What is the color coding of voxel?
Red is one camera, green is the other camera.
Right. But the intensity of a voxel.
The intensity of the voxel is the inverse of the RMS error of the points from the camera's point of view at that position.
Inverse RMS error.
Yes.
And then you have a threshold for how low that has to be a full red.
Yes,
Can you change that threshold?
absolutely.
That-
But I can also change that in Voxeltastic.
Yeah, but if you change that threshold to make it require a larger threshold to draw it as red, then it could be that a very small number of points are full red.
Yes, but I'll play with it and we'll see. But in general, when you ask questions like that, if you can come over to Mike, the more involved questions. No, I mean you already have. Like not now.
Yeah.
I'm just saying in the future.
Yeah.
Somebody said, "Can you commit, please?"
Oh, which aspect would I commit? Which thing?
I don't know. That's all they said.
Yeah, if you can find out, whoever was that wanted me to commit, just tell me specifically what aspect. Do you want the tools committed, or what do you want committed? Or do you want the combiner committed?
I'm asking right now. So. The axes on voxel magic.
The axes on voxel magic.
Tastic.
Voxel tastic.
There is no axes on Voxeltastic.
I'm guessing that's what they want.
Oh, you want me to add the feature? Okay. What I'm actually going to do is I'm going to make it so...
Commit to help getting axes on voxel tastic.
I'm just going to make it so it points up in the Y direction. X direction? Y direction. Which way is up in the headset?
I think it's Y.
I think it's Y. I'll make it print up in the Y direction. So I'll say, and dy is that, and dy is less than 0.234. Okay, it'll have a little bit tail, or it'll just be pointing in the... I'll make it do in X and Y both. Now it'll have a little bit of like a coordinate frame thing going on. Let's see, how well did this one resolve? Good, good. This one resolved to, at worst, 666 micrometers. So that's, micrometers, that's right? That's millionths of a meter, right?
I believe so. That's incredible, actually. That...
It is possible, science.
Yes, it is. It is
Wow.
actually resolving to right here. This one looks like the worst one to resolve, and the best one is at 47 micrometers. So I think this data is going to look pretty good.
It's impressive.
Um,
It's incredibly impressive.
although no, you know what? No. Because they're closer together, they'll naturally resolve to lower errors, and that's just so it's really not that good.
Just
that
an
it's,
artifact of...
it is an artifact. Okay. I was really excited there about it, resolving so tightly.
Oh yeah, I guess they are more tightly packed in that direction. How fast is your algorithm? Could you run it 90 times per second?
So the algorithm for this only needs to get run once ever. Once it's run once, we know the position of the lighthouses, and then it's much easier to do the inverse of this problem, which can happen super duper fast. Let's make sure it's the right one. L lighthouse, good to go. Let's run it again for the R lighthouse. Boom, our lighthouse done. Combined the data. Ooh, that's nice. It's still relatively weak, and that's odd that there's this one point out in the middle. I'll make it so it's a little bit clearer.
It looks good though.
Whoa, that was...
Woo!
That's weird.
The mushrooms are
interesting.
good.
That's a bug in Voxeltastic there.
I like the drugs.
Charles, I think your laptop is rebelling.
Oh boy, yeah, it's not liking that. Okay.
Are you using a constant threshold for the color map?
I don't know what a constant threshold is.
Where everything under a certain RMS is bright red. Are you weighting it based off of the?
No, it's the color red is independent, but the opacity is dependent on how red it is.
Right. So, right. Yeah. So the full opacity, is that set to a specific value of RMS, or is that dependent on the smallest RMS you find in the?
You ask questions. Come over here.
Oh, okay.
I'm wondering whether Voxeltastic is using an absolute or a relative color scale. Is the color scale dependent on the data, or is it absolutely determined as, a specific RMS in meters is or meters squared is set to a specific opacity?
Okay, so to answer that question, I have that code in two places. One is right here.
Yeah.
where I take the RMS error and I multiply by 10.
Okay.
And if it's greater than 1, I just don't worry about it. It's just I set it to 1. If it's less than 1, which means that it's better, then I make it less than 1. And then I save the inverse of that out to the file.
So it looks like you're not at nowhere are you computing the min or max or the average or anything.
No.
So I guess my thought is that let's say you have a situation where there are a lot of points that have a low RMS, but there's one point that has an even orders of magnitude lower. So then all of them would show up as a cloud.
I would see that in here. So what I would do is I can set this higher. So I can set this to say like 200
I see.
or like 239.
So why is there a huge hole
Right.
in the middle of the red?
So that could be the position, right?
One of these, yes. So
Right. So I guess what I'm saying is that it might not be that huge green cloud. It might be that those are the only reasonable points.
oh, that's a good point.
And then
Okay.
it depends on your color scale. You just had a color scale that was just so generous, right? That everything looked like everything looked like a good fit, but there was only one point that was an even better fit, right?
That's a good point. Okay, so
Sorry, the yellow thing on there, that's the headset, right?
yeah, sorry, the yellow thing in the middle is the headset. And I was going to try to make it an axis to point which way was Y plus, but I messed that up somehow.
What's the one guy wants you to commit it so that they can add the axis. They want you to commit what you're working on for this so they can add the axis in.
Okay, just so you guys know, the axis add is going to have to happen. I guess it could happen in Combiner. That's probably the best place to put it would be in Combiner. Let me go make a makefile for Combiner so that that's at least reasonable.
Yeah, that's what they said. Please commit combiner. That's it.
Make file. I started writing a C program in a make file. What is wrong with me? I started down including in a make file. Oh, combiner. Combiner, combiner.c, GCC, $, clean, rmrf, combiner, make, combiner. Let's make sure it runs. Okay. This looks like it's running. Okay, so I'm going to go commit combiner now. What is it? It's git-n, right? Git, don't recursively commit. I don't remember the command for that. Recursively, I don't want to add recursively. Git add, no. Does anyone remember off the top of their head what the command is to commit a folder but not everything in the folder?
No.
If you move the files out of the folder, and then commit it, and then move it back in. That's
Dave is suggesting copying the files out of the folder, committing the folder, and then
moving, not copying.
moving, not copying. Oh, good grief! This is it's got to be like -n or something.
Wait, that doesn't work in Git. It works in Mercurial and SVN.
I don't know. SVN is what I'm more familiar with
Yeah,
right
it
now.
works in SVN, but it doesn't work in Mercurial. Git won't actually. Gosh,
I'm familiar with the CP and SCP commands, and I'm very familiar with the overwrite.
Okay, fine. I'll just copy the file, move the files out, and we'll go from there.
Somebody's showing how to. There's one way to do it.
Git commit ls dot. Well, no, I can't commit the folder inside the other folder until I commit the folder that has the fold. How do I say that? You know what? I'm just going to move the files out and commit it.
Technology.
Woo! Version control. Yeah. The wonders of Git.
Good. That's fine. Everything is fine now.
Everything's great.
Fine. Okay.
Wow. Chat. Special.
Okay. That's working. Totally works. Everything's fine.
Commit some of that bacon, please.
No, we're not committing the bacon or what the bacon is going to be a part of. Okay.
You know what the bacon is going to be a part of.
Bacon pancakes?
Nope.
Our mouth.
Bacon popcorn.
Bacon pancakes.
I still think you should make some Old Bay popcorn.
That's horrifying. I really do want to find a good way to make like savory popcorn that isn't just oiled and then powdered. It's gotta be something else you can glaze it with.
I wasn't joking when I said you could put it in the caramel. It will work. Try it.
I think you're insane.
What?
Okay. So that's all up to date.
Old Bay and caramel and then cook popcorn.
So now I guess the point would be try to track down in these clouds, figure out what's going on.
Tried it before.
I'm not really sure myself though. That data looks pretty good. And the ranges are pretty good. I don't really know what's up with from the red point of view. So let's actually look at that right now. Plane test.
Yeah.
Cam find.
I don't eat
Let's see, which one was this? Was this the good one or the bad one?
Old Bay on everything else.
This is terrible, terrible data. Let's take a look and see why.
Somebody wants a close-up beard can.
There you go.
Some right away.
This data actually looks pretty good to me.
Oh, I think what they wanted you to do is to take the Vive and move it close to one and close to the other and compare the results.
Oh, I can do that.
That's what they wanted you to do before, not turn it.
Okay. Sure. I'll do that in a minute. We'll do Vive L and Vive R. Okay. Although I'm really confused because this data doesn't look all that bad. Am I calculating RMSs wrong?
You're on your own on that one.
The only RMS that I calculate is, audio output.
Math and me have not been friends as of late.
This data looks pretty good.
Especially with my circuits.
I mean, it's a little off,
We're
but
really not friends right now.
it's not that bad. Why does it think it's off by so much?
Right now.
4 centimeters? That can't be right. I guess it is right, even though it's a very small amount. So this is in radians in this graph. I guess that makes sense that it could be off by that much. It just doesn't look like it, because it would be like on the surface of the thing here to here. I guess that's 4 millimeters.
So
Yes?
does it calculate the position at discrete voxels and then pick the best one? Is that what you're plotting here?
Yes. Well, actually, what this does is it calculates the best area of voxels to look inside of from the best voxel it found the previous round.
Okay.
And then it searches in there, and it searches in there, and it searches in there, and it
so
searches in there.
it narrows.
It does actually narrow down. It's like kind of like a binary, not binary, but like a multi-dimensional iterative tightening search or something.
Hierarchical.
Hierarchical. I like that word, Dave. That was R Lighthouse. Let's look at L Lighthouse. Okay, I'll take this data and take a look at it in the graph and see if it's spot on. Delete. Okay, the other data looked good, but this looks amazing. Yeah, okay, I understand now. The other data, you could see the red dots behind. You can't see the red dots behind on this one. They're just... Look at that data. It's so good. It's so good.
You should post this to Data is Beautiful again.
Do I really need to post this? I don't think... No, there needs to be more context as to why this is so beautiful.
Yeah.
Okay.
As it is, this doesn't
So
look beautiful on its
the
own.
setup for this data, the second data, is with the sides of the lighthouse, or sides of the HMD pointed to the two lighthouses. Let me update that in here. Okay, so right now I think it's time that we go and point the lighthouse straight on at point the HMD, I can't get those two words straight, point the HMD straight on at one lighthouse. So it'll be like crystal clear, clean as day, can't be confused. It'll still be confused, I just know it. So somebody posted, real quick before I do that, somebody posted this, the Lighthouse USB protocol.
Interesting.
But this doesn't give me... Gives me acceleration. HMD lighthouse sensors. Okay, but that's still HMD lighthouse sensors. That's not actually lighthouse sensors. Mr. Redbeard, if you know if this is actually like the HMD, although this has got to be the HMD because that's where I'm getting the data from. What I'm wondering though, is there any way of getting light data from the lighthouses themselves? And I don't see it. Which, by the way, some of this is, man, Nerol, you're gonna have to update some of this based on some of the things we found. What is this? Wireless? That's the wireless thingy. Trigger button, touch movement. This is all the Watchmen. Yeah, it's all Watchmen stuff. So no, I don't see anywhere in this document it's saying where it goes. Got Mr. Redbeard.
Although a handful of them do that, and then they're like,
The
oh,
GitHub
this is actually really interesting.
reference
But I have no
does
idea.
not show anything about
Somebody wants you to
Lighthouse.
pull the lighthouse apart.
receiving light
Yep,
data.
needs to be banned. Already done.
Let's check this. Oh, actually, I should show you guys the photodiode that I intend to use for my experiments with this. It's cheap. Cheap. Okay, so this guy was one that... Okay. That's interesting. This guy does have a bit of things about the position calculation of the... Although he's doing it at a much smaller scale. And he's doing it based on the known positions, and it's using math. What I can do is defer this to Dave, though, if Dave's up for looking at it.
I'll take a look at it.
Uh,
How do I get the...
so Dave, what you're going to want to do is go to the GitHub Live Survive page and look in issue number 3, third post from the bottom, and see if you can
URL right there.
make any sense from it.
It was trim.net, TRIMM.net/lighthouse.
No, we spelled Unit E correctly. As I understand it, so it was before the game engine, right?
It was like the same year that their company was founded.
Okay, so yeah, there is no relationship between Unit E Technologies, the people who are helping make this happen right now, and
And Unity.
Unity, the game
Technologies,
engine.
Which makes the game engine.
Yeah, very, very different things.
Except for the fact that one uses the other.
Yeah, well, we use them, but they don't pay me, so... Okay. So a few. Oh, so that's right. Now we're going to go, not cam find. We're going to data record. T, and this will be Lighthouse L, or HMD pointed at.
Which one was it? Yeah, that one.
Let's go put the lighthouse, or the HMD pointed at that lighthouse.
So, I don't know if we can turn these lights on live on Facebook. I hate Facebook.
Okay, it's like I can see it. So now it's pretty close to the other lighthouse. It's actually on the floor. You can't see it from. It's right there. The lighthouse is right there. It'll focus. Come on, camera. Focus. Focus. Come on, you can do it. Come on, focus. Camera, focus. Focus.
Jiggling it around and help it get in focus.
I don't know. It's just, whatever. It's not going to focus.
Did you smudge the lens down?
Did I? I don't think I did. No, it's fine. Whatever. It just didn't want to focus. Yay! It's collecting data. Let's let this run briefly. That's a lot of lights that are in view.
So, somebody was asking what exactly Unit E Technologies does. We mentioned that they made Neon FM. Was there anything else you'd like to add?
I'll bring up the site in a minute. Recommendations for learning C, Linux. I know that seems kind of odd, but if you start actually using Linux and you have the environment there in Linux, it really makes it easy to be like, I want to do X. And you can go get whatever libraries you need and all of that to just get moving. C in Windows, it's a lot harder to get all the pieces and bits to make something useful and fun.
Although now, since you can use the Linux embedded in Windows, you can actually get started without diving wholly into the waters of hell that you're not ready for.
Well, I mean...
No, that's terrible. I tried doing the Linux on Windows thing. Everything is broken. You type in dmessage, and it just says not implemented.
Really?
You type in like live USB, broken.
I'll try it right now, because I have it on the air. So what all did you say was broken?
Like LSUSB. So anything, what I'm suggesting is in Linux, like if you want to access hardware, it's really easy in C.
Yeah, with
And-
hardware, it's still lacking on this.
Yeah. HMD pointed at Lighthouse, or sorry, no, get it, camfind.c. I think L, we should be on the L one, so. This, oh, I didn't edit it yet.
Somebody would like to know if you accounted for the slightly different origins of the X and Y sweeps.
You should not need to account for different origins of X and Y sweeps that I'm aware of, because the center of the effective sweep, like not where the actual emitter is, but where the axis that it's rotating around is, should be centered inside of the, like this one goes this way and this one goes this way. It should actually have a point in the center of wherever we're considering the lighthouse to be. Sig fault.
Broke it.
Yeah. Ugh. Huh.
Charles, what are you doing?
Let's try valve grinding it.
Love how metal that sounds.
Valgrind.
Start valve grinding things.
422. It says the problem is here. I guess that's that line, maybe? Oh. Let's up that. Okay.
You literally just capped it too small.
Yeah, I had the cap too small. It did not find that very well. Or at least it doesn't think it did. Although, you know what? That's an absolute space. So maybe this is actually really good.
Well, let's see it.
Let's see what the data... Let's see what it looks like in here first.
Yeah. Valgrind is for finding memory leaks, right?
Valgrind is for finding memory leaks and anywhere that you're violating any kind of memory rule. Valgrind actually runs an x86 emulator, and so whenever you do anything with memory, Valgrind will watch you like a hawk. It's like Santa Claus. Okay, so from this thing's point of view, that's what this data looks like. I'm thinking it's pretty good. That's definitely the sort of thing I'd like to see. Let's see what it looks like, that particular camera in Voxeltastic here.
UI Wizard says Valve uses Valgrind in-house.
I would hope that everybody uses Valgrind in-house. Valgrind, I don't know how to pronounce it.
Valve grind is cooler.
Valgrind sounds way more metal.
Ooh, that's totally wrong. Let's try that again. Not an RGBA map. Oh, that's not right either. Or maybe it is?
DM says that their code was so big they couldn't even run Valgrind on part of it.
This looks super weird. I don't even know what I'm looking at here.
It is... Whoa. Whoa. Whoa.
What is
the
up
heck?
with this?
There's a plume of smoke above
The...
the invisible smoke from.
Oh,
the
wait, no, the HMD is not in the center anymore. It's pointed right at it.
Yeah, it is pointing. Oh, that makes sense. Okay.
No, because, well, the HMD's tilted, so that's almost perfect, yeah. It's right.
Right, but why is...
Want,
It shouldn't be that
Yeah.
bad. That's such a large search area. And not to mention, there's two locals. So I was really hoping I'd be able to use like gradient descent or something and just find the right answer, but...
I don't even know how to pronounce that.
Pronounced what?
This Wikipedia says it's pronounced Valgrind. So, yeah, something.
Yeah.
Something I can't say.
Rob, if you pronounce that yourself loud enough at the screen, we'll hear you in our hearts.
This is very interesting.
Somebody
So I
says
don't-
that's what Trump's wig looks like in an MRI.
Well, Adam walked away, so I'm just drinking.
Yeah, I don't know what's up with this. That's very strange.
Yeah, it's
Uh,
like hard cider.
Huh.
That's why I was like, it's more like champagne, but not.
I don't know why that would be. I mean, it's kind of right. Like, that's kind of where it is.
I'm a terrible person who doesn't drink much beer, but
Is this homemade?
No.
No.
This is,
Um,
You wanna try some?
slides.
Oh, okay.
Not
Whatever.
beery, but it's not cidery either. I don't know what it is.
I'm just curious. I'm just going to try the other Lighthouse right now.
I'm more of a hard liquor person.
Well, I have two kinds of bourbon.
but I need to be able to drive home, so no hard liquor.
Oh, there's a flashlight. Here, I can just yeah.
The other lighthouse, it's like, I kind of have an idea as to where the thing might be.
Is a tease of a taste.
The other lighthouse is aware that it's, you know, somewhere on that side of the room.
Do you need these?
What the hell
Here,
did you
just
do,
try to
Charles?
put it on the bin.
It knows, the other lighthouse knows it's, you know, about that far away. That's really cool that the shape that the probability curve for the other lighthouse makes is that nice and pretty, but
That's pretty neat.
It is a short.
That's a very cool,
yeah. Huh.
Oh, also they were saying that you may want to move your coffee table over a little because the edge of the suite might be hitting that.
No, I actually looked down. I put my head on the floor where the thing was, and it was totally not.
Okay.
Oh, that is so weird.
I don't know how to describe this, but it's good.
Yeah, I don't know either. Yeah.
So yeah, clearly the other lighthouse is not getting enough points
A
to
little bit of a cider bite to it, but not. But it's more sweet bubblies.
know where it is.
And it's a
Punch
champagne
myself in
cider.
glasses.
This is the stuff. Lambic.
Okay. Sorry. What was the next thing that we were supposed to be doing?
Never heard of that.
I have no
Brandon
idea.
mentioned it like this
Yeah.
week.
Oh yeah.
I've been derailed with
The raspberry
apple
is
something.
really popular, and you can.
Adam, stop derailing people.
But, hang
Let's see what the Dave. Have you been reading the article that the guy posted in there?
Yeah, I'm looking for
Belgium.
Okay. Let's see. What else was actually on the original agenda? So we've done that. We've gotten the points and the normals for the Watchmen. Oh, no. Has anybody yet in chat found a list of the points and normals for the Watchmen?
Hang on. Somebody
Specific-
asked what the beverage was being discussed in the background. Let me answer.
Here, I got it.
Specifically, if anybody has access to the points and normals for the Watchmen controller, that would be super cool. I tried asking the Watchmen the nice way through the HID interface, and it totally did not tell me anything. So, visualize the Lighthouse probability data in Voxeltastic. Totally did that. Improve the Watchmen disambiguator. We're gonna have to work on that. And collect more data as people want it. So I think the other thing some people wanted was for me to point the
Camera at yourself.
that's fine. Was to point the head mount display at the other lighthouse and see what it says. So we're gonna go do that right now.
On that if you
Oh, there's not much left. I'll probably kill it. If you don't mind.
I'll take a small or if I mean, there's any left, or if you
Here, take a little bit first.
Cassis is all mine. Also got
Did you
several
try it?
flavors. No, I haven't tried it yet.
Oh,
It will be tomorrow.
Yeah, I've never even heard of lambic before, but it's good.
glad I could share some knowledge.
It probably should set this up so the camera was like watching all the people working on the couch.
If they were working, that would work.
Okay, no. It would look like they're working.
Uh-huh.
Except, passing the bottle.
Yeah, well, that's a normal thing, right?
It is for me,
So we'll start tracking some lighthouse data here.
depending on how much work I'm doing.
So right now it's mostly pointed at the Lighthouse R, and we're collecting that data.
I'm gonna have to get some people this for Christmas.
Hey, Crazy Red, I have an idea. You take some of these screenshots of the voxels, and you make a billionaire, and give me $1 million, and we'll be set.
Crazy Red is named after a fake art dealer from Animal Crossing.
Fitting.
I do not have to apply any rough estimations of where the lighthouses are. This is just purely based off of position of of where it is, what it thinks it could be. Okay.
I see. Here, looks like he's using for lighthouses.
Do you have to supply rough positions?
No.
For lighthouses?
I already answered that one.
Guy says we all look like we need some Adderall.
Is there anywhere?
It's not wrong.
Is there anywhere I can get lighthouse data?
What kind of lighthouse data?
Particularly the
Purple
angles,
kind.
the angles of the
Yeah, in that thing.
TVs.
Oh, I have in
Yes,
the
there-
thread. I have the raw times, but you would have to parse it to get angles back out.
Okay.
Which you could just run CamFind and then get the angles from there.
Okay.
In CamFind, it loads in here. David, I will pull up CamFind in this thing, and I will walk you through it on the screen.
Okay. Great. 'Cause- okay.
Okay, so inside of CamFind, the first thing we do is we load data, and we say either R or L for R for the right camera or L for the left camera. Sorry, I say camera, I mean Lighthouse.
Which is not a camera.
Okay, you know what? Load data,
Do we have
Lighthouse.
GitHub?
Say what?
Where do we get the data from?
Oh, it's in GitHub issue number 2.
GitHub issue number 2. Okay.
Yes, in GitHub issue number 3. Issue number 3 is where I have a bunch of the example data. At any rate, so in the camfind.c, I go load the data, and what this does is at first it loads all of the. Sorry, it's down here. First, where is it? Here it is. First, it opens up correct hmdpoints.csv, which is in issue number 3.
Okay.
Then it opens up hmdnormals.csv, which is in issue number 3. And then it opens up whichever file you want to do, like R, and it reads out all of the Lighthouse data from that file and only uses the R Lighthouse, and it figures out the average angles of all of the photodiodes that it sees. And it does that by just iterating over the whole thing and converting them into radians from ticks. So that seems to actually work pretty well.
What was the third one that we needed?
You need to actually have the Lighthouse data. So it's the first one is correct hmdpoints.csv. The second one is hmdnormals, and the third one is the actual light data. And the actual light data I've posted is like the most recent thing in issue number 3.
Okay.
I'm going to be posting a little bit more soon. Let's make sure it's talking to number R. Look at that data. It's off by a few millimeters, but that's still so much. Let's see what it says if I copy this data into here. Automatic. And
Charles, apparently your lighting is making you look like a strung out coder.
I am a strung out coder.
I'm trying to be nice and blame the lighting.
I think it's the bags under the eyes because I've been up all night, every night, doing the stupid Lighthouse stuff.
Looking at lighthouses too much.
Yeah, staring at the infrared lights pouring out of them. Me begging the lighthouses, tell me your secrets. Meanwhile, Ben is just there being like, ha, I put those secrets in the lighthouses.
Is that with you guys again?
Yeah.
Nice.
I don't know if he's like actively in the channel right now, but he did say something earlier.
Who?
Ben, the guy who coded. Oh my gosh, look at how gorgeous that looks. Oh, yes. Yes.
That's it.
Yeah, it totally is like, yep, it's right there.
That's
Boom.
pretty tight.
But I think it's wrong.
Wait, that like exploded.
Maybe it's right. It's probably right. I think it's right.
Where did you move it?
Yeah, I guess that is kind of right.
Oh, yeah.
Because it is in the frame of reference from the whatever it is, the camera's point of view.
It's a little bit below, yeah.
Yeah.
Issue 3 and 5 contain maintain the controller calibrations you are looking for.
Issues 3 and 5. I think we only needs to be in issue 5 if you're talking about the controller calibrations.
Just that you were looking for info that is in those, that is pasted there because the link can't be pasted.
John says he's not seen a person so obsessed with lighthouses since.
Neral. Oh, hey, Neral. So Neral is the guy who did all of the initial Lighthouse Redux stuff, which is amazingly well documented. It's almost all correct, and I don't know how he was able to get all of it. So that is truly amazing. I'm so happy for his work. If it weren't for his ground laying work, I would not have even tried to do this project. But I did actually try the exact same thing to get the data from the controllers, and they don't say anything. Unless I have to be plugged in by USB directly to the controller. Do I have to do that? Neral, do you know if I have to be plugged in by USB to get that data?
Also, pull requests. The axes things in.
A pull request. Oh, hold on. Let me get this data committed or added to the issue first.
By the way, if you're into electronic audio, you should check out the thing that my buddy Paul made.
Sorry?
If you're into electronic audio, you should check out the thing that my buddy Paul made. He made
okay.
Basically like a sound generator noisemaker out of
cool.
a bunch of 555 timers and pots. And
Nice. That sounds similar to the way
pretty impressive.
old Namco boards generate sound. They use a bunch of like 74 gates and whatever to generate a 4-bit waveform.
Yeah,
and then
he
proof
did
it out
that,
of
but
DAC.
then he was working on something more advanced that was supposed to use either an Atari chip or something with like MIDI support and all. I don't know if he ever finished that one, but he spent a lot of time working on it.
I should show you a thing because we're trying to do it.
Can you guys do that later? Like take a note?
Oh, yeah.
No.
Let's see here. So you guys, you said I had a pull request waiting. Oh, hey, it says pull requests. Better axes, comma, I think. I'm not sure what's going on here.
Don't hurt to try, you can always revert, right?
I would make cell 255 for each. Sure, why not? Let's make this the thing. This looks good. I guess. Sure, fine, whatever. Can I merge this without hosing that file? You know what?
Well, just copy the file outside of the folder for safety.
I'm gonna just check out my stuff. I don't feel like dealing with a merge right now. So I will just accept what they have, wholesale, and hope for the best. Merge pull request, confirm. Get pull. Camfind.c.
For some reason, Jamie suggests copying camfind.c to 10.
What?
I don't know. Just look at the chat right now.
Copy camfind. Oh yeah, I could have done that. Oh well. I don't know which data set that just operated on. Let's just try it. Browse, raw, Lighthouse. Is that it? Tools, plain test 2. Oh, interesting. I have no idea what I'm looking at. Oh, they're like axes that come out from the middle, but I don't know which one is positive and negative. That's still pretty cool. So which one's Y and which one's X, I wonder?
I only see two going like the same direction there.
There's this other fainter one that I guess it's more. I'll make it so it's easier to see.
I can barely make it out on the. No, I can't see it at all in the video actually.
Now you should be able to see it.
Give it a sec. Yes, now I can see it. It's green.
Okay, that's neat.
Some labels would be far better, but however, from the looks of things, it looks like the green is directly in front of it. Whereas the blue is left, right. So I think Z is forward and backward.
No, Z would be like this way down. Although, wow, that's a weird shape.
Yeah.
Faint axis when dy is small.
Don't know what's causing that. That's very strange. Okay. Point is, the thing I was really, really hoping that this data would just naturally, like, converge. Totally not how it works. Huh. Okay. Well, that's interesting. Has Neral said anything in chat about how to actually get the data from the lighthouses short of plugging them in? I don't think anybody anybody's said how to do that yet. Collected more data as people want it. I'm going to need a break right now anyway. Dave or Michael, did either of you have anything you wanted to say?
Yeah,
Like talk about or anything? Dave, are you ready or do you want to have a little while longer? Okay. At the very least, we could just play an advertisement for a minute and then... Oh, you guys wanted to know what Unity Technologies was.
Yeah, play a Unity advertisement.
Yes, we will play
Advertise
Unity.
us.
I think we can.
So, Unity Technologies is this thing that Adam, me, and Eric Yaki, we've gotten together and we've done a number of different projects, mostly commercial, thank goodness. Everything down to making, how many was it, like 8,000 crosses?
It was about 5,000.
5,000 commemorative crosses for the Pope's visit to New York.
Someone just found us on Google and we're like, hey, can you do this? And we're like, sure.
They can't hear you if you're over there.
Oh,
Can you guys hear him if he's over there? Did you guys hear
on
him?
the stream has stopped scrolling, by the way.
Scroll to the bottom of the chat window on your
Oh, I can't do. Can you, Adam?
YouTube on the laptop.
So at any rate, so we do a lot of custom engineering work. We have a mill. We have a bunch of just mechanical stuff that we do, and we do make arcade machines. So
I can't scroll on here.
Talking.
say what, Brendan?
Not you.
Okay.
Sorry, I just.
Let's see if I search that. If I can find a good. So like the newest game that we made and we debuted at IAPA was World's Fastest Drummer, and this one is done in conjunction with Fun Company and a few other groups, and it's just a game where you have to drum as fast as possible left and right, and you have to alternate and vie for the best score of the day, month, etc. So that's another big one. So if you guys have any arcades or anything like that, we've done World's Fastest Drummer. We did we did Neon FM, which is a a video game that's like a regular stand-up arcade. We have US, and we worked with Andamiro, a very large Korean distributor, or Korean manufacturer and game company, on the Korean version of the arcade cab. That's just some of the things that we do up at Unity. Adam, can you think of anything else? Oh, we also do custom signs. So anything involving WS2812s or other innovative lighting stuff, we totally mess with. Anything else you guys wanted to know, or anything, Adam, you can think of Unity-wise that we should mention?
No, not really.
And by the way, you guys can totally take it as a hint. There is a reason why they got me an HTC Vive.
LOL.
Oh, okay. I need a brief break. I'm just gonna keep that scrolling, and then I will play an ad.
You just have like a button to play an ad?
I think I have a button to play an ad. Yep, right there. And I'm curious, whatever, when they get back, we'll find out who actually got the ad played at them.
Well, it's playing with me. I guess I'll leave it run. It's not hurting anything.
New caramel popcorn should be done in 20 minutes or so.
20 minutes?
Oh, that's why it's not.
What?
Gotta bake it, otherwise it's all gooey.
Okay, good. Everything's fine.
Playing an ad.
How long is your ad?
1 minute and 5 seconds. 30 seconds to go.
Why would you have YouTube? Okay, to be fair, I'm really glad you YouTube Red people, because I make it's like 10 times or more, I think it is, per view off of YouTube Red views than I do off of regular YouTube views with ads.
Does Unity need interns?
I don't think we need any interns this summer. We have had interns in the past, and it worked out really well.
I would never turn down interns.
Adam would consider you as an intern. Just apply, though. Apply. Email us and apply. Do you guys have any? Did you want to mention some of the stuff you were working on, and maybe if this would be of interest to you, or if anybody else who's interested in the Vive stuff would be?
I mean, I could just talk about what I was doing really briefly and how it kind of relates to this.
Yeah. Okay. I mean, there's a bunch of people who like Vive stuff.
Sit this down before it falls. Alright, so while Charles is taking a quick break here, I figured I could talk about my project with the Vive a little bit, to see if anybody was interested. I've been working with my University of Maryland, Baltimore County, since this spring. So I've spent... Yes, Charles also went there. Been working on a research project related to the HTC Vive, where we're using it to perform human studies about reaction times and how people react in different situations. So what we're doing right now is a simple pilot study to make sure that we can use it in this capacity. And I programmed a basic shooting range simulation in Unity with 2 types of targets. One you're supposed to shoot, one you're supposed to not shoot. And the goal of the study is to see, after explaining the test and allowing them to take it once, comparing a control group who just takes the test again versus a group who is trained on how to better take the test and how to avoid shooting the wrong targets, to see under a stressful situation how they respond, and see if we can measure differences in their abilities to perform through data gathered from the Vive. While they're taking the trials, it's going to record information about the position data of the headset, position data of the controller, as well as every time they shoot, when the targets appear and disappear, as well as we'll be taking physiological data on each participant, such as EEG, heart rate, and breathing. And after that, our goal is just to make sure that we get good data out of this project and see where we can go from there. There's a lot of other studies we're interested in, but we need to make sure that it's possible and we're going to get useful data first. So, see, even when you're sober, you don't understand. How much have you been drinking? Even when I'm sober implies quite a bit of drinking.
Do you, I mean, if you don't want to talk today, that's okay too. Okay.
Yeah, my study is still, we're waiting on approval, so we haven't really done any test subject data collection yet, so I don't have too much to say about that. Part of the study involves inducing stress through some minor electric shocks, so we have to wait until all the people who go and make sure we're not doing horrible things to other people approve us.
Michael mentioned there was a cool story on NPR about TDCS.
TDCS?
A similar
Who's that?
experiment. A similar experiment to yours, the one that you're researching. Do you
Remember, they
need
can't
to
hear you.
ask?
So, what was that station you were saying that there was a similar
NPR, like the,
on NPR? What?
Story.
Who did the study?
someone did an experiment involving TDCS.
TDCS. Okay.
Yeah.
Brendan,
But
speak
we might
loudly.
need to know what that is.
Okay.
So maybe ask what TDCS is.
Brendan, speak loudly.
Apparently they can hear me, they've said.
What would you like the perfect intern to do?
I think that's a Unit E
Yes.
question.
No, that's not a question I can ever answer because I never know what I'm going to do.
It changes very routinely. Unity does a lot of stuff, so the definition of a intern's job would change considerably from day to day.
Yeah, like I just don't understand how people can define their jobs because all I've ever known is just, hey Adam, figure out what the heck to do. All right.
Oh, okay. Yes, I do remember reading about that study, Michael. They did a thing where they were stimulating the brain, trying to induce stress. Ours is similar, but it's a bit different in that we're trying to... We already know that our method will induce stress, but what we're trying to study is, can we train people through using the EEG data and the game or the simulation, can we train people to improve their response and their ability to operate properly in a stressful situation or to inhibit responses that they've become habituated to when they're stressed out?
I mean, you actually write full stack engineer product designer just like every other person on GitHub.
Yes, all the people on GitHub. This is the internet. You are who you say you are until you prove otherwise.
I should
God
probably
helmet.
change my GitHub personal bio to
Not
I
sure
don't
what-
care that you're a full stack.
I'm not sure what you mean by a god helmet.
I think probably something that involves a smite button.
DK1.
I think
the
that's
original Oculus.
the Rift DK1.
No, sorry.
Maybe is a collector's item, but other than that, I can't see much use for it.
Yeah. Not when there's this, the HTC Vive.
Oh, okay. So they were trying almost the opposite of us. They were trying to induce stress through the immersion and then stimulate it to reduce it. Okay. Yeah, what we're doing is not quite as extreme as anti-pedophilia training.
What?
Somebody mentioned that what I was doing sounds similar to the method they used to use to train pedophiles to not look at children.
Here's a kid. Here's an electroshock.
The ultimate totalitarian dictatorship.
No, no way. Castration
Well,
would be.
I for one welcome our robotic overlords. They are coming.
But first, we will be the overlords of robots that have taken our jobs. Then we will engineer better overlords that are not us. And then none of us will have jobs.
Oh yeah, that's a good one. Okay, whenever you want, Dave is ready with.
Okay, if nobody has any more questions about anything that I've done, I know it's not a whole lot yet, but Dave actually has some stuff that he'd like to speak about as well.
I'll introduce that.
Recommend it. Yeah, go ahead, Justin.
For this project, we are trying to minimize the total number of dependencies on anything external. So that's for a few reasons. One, because the reason this project started to begin with is because I ran out of data on my cell phone plan trying to get all the dependencies for the OSVR Libra Vive library to run. Which was really annoying. But more importantly, in the long run, this is really kind of targeted more towards the ESP32. So we really need to use as lightweight and as minimal like library stuff as we can in order to keep everything moving smoothly on as many processors and targets as we can. So one of the things Dave has been doing is, in order to do the Kalman filter, we have to invert matrices. And in order to invert matrices, there's a bunch of operations you have to do that. And a lot of people use is LAPAC.
LAPAC, yeah.
And that's not something that was going to quite work for us because of some of the size and additional things surrounding it. So Dave is going to speak a little bit about what his effort has been. And in case you guys could use some of what he's produced now, you guys can just go check that out of the Live Survive repository.
All right. What Charles has said is just about half right. So LAPAC is incredibly easy to install in Linux. The package or the precursor package has been around for, 50, 60, 70 years. My advisor in grad school was one of the people who wrote some of the numerical codes in Fortran. And the problem was that I tried to install LAPAC on a Mac, on a MacBook, and there were all of these dependencies, which I was surprised by. And in Linux you just say yum install or apt-get install, LAPAC, and it installs BLAS, and then you can invert your matrices calling this. You actually have to write your own prototype in C to call a Fortran function. But in Mac, there was something called Homebrew, which did have a LAPAC package, but it depended on a lot of other things, and I couldn't actually get it to work. So I wound up rewriting one of the numerical codes. I used LU decomposition, which was invented by a famous computer scientist named Alan Turing. So these numerical codes have a place in history. Alan Turing based his algorithm off of row reduction, which was developed by an incredible mathematician, astronomer, inventor named Carl Francis Gauss. Right, so it's a very classical thing to do. For me, it was kind of fun to be able to take a step back and try to implement a classical algorithm. Now, one of the things, the code, we're dealing with 36 by 36 matrices, unless we find a better way of working with it. And 36 by 36 matrices, and the code that I we can invert those at about 20,000 hertz or so on my Mac. There's a few. Can people hear what I'm saying?
Aim it at Dave.
Yes.
You're kind of talking up at the TV instead of.
Oh, I'm sorry. I was looking at the. Okay. Can people hear what I'm saying now? Is that better? Basically, in the one sentence, I was working on rewriting a linear algebra package because I couldn't install LAPAC, which has been around for 60, 70 years, or at least I couldn't install it on a Mac because of dependencies, and there isn't really a whole lot of support for it, which really surprised me. One of the things that I wanted this code to be is really fast. And one of the things I was a little bit concerned about has to do with the way that C handles pointers compared to Fortran. So C doesn't have the same kinds of bounds. The compiler doesn't know as much. If you have A, B, and C, and if you're reading from pointer A and writing to pointer B, and you're interweaving these operations, the compiler doesn't know that your writing to B isn't going to affect the reading from A. So that can slow the compiler down if it has to wait for that write to finish and for that read to finish. They could introduce additional stalls to wait on it because it's being conservative. It doesn't know if you're writing to this memory, how do I know that doesn't affect that other memory, right? So Fortran knows that these are arrays. C doesn't know that. So one thing that I did with this library was that I made everything in macros rather than using functions. By putting everything in macros, the compiler, I don't have to pass a pointer. The compiler can actually see where I put the local variable. So I at least think that it should be able to be optimized more aggressively than if I had written a function that had to pass data through a pointer. LU decomposition is where you do row reduction. In fact, do you think you could pull up a Wikipedia?
Wikipedia?
Yeah, about LU decomposition.
Okay.
So you do row reduction to convert your matrix into what's called a lower triangular and an upper triangular form. So if you scroll down, you might be able to see some examples of a lower triangular and upper triangular matrix there.
Walsh matrix thing here?
No, not that. Just those blocks of matrices there. You see that the one in the on the left is your original matrix A that you're trying to invert. The one in the middle is a lower triangular matrix, and the one on the right is an upper triangular matrix. So for those of you that have taken linear algebra, the first thing you had to do was row reduction. So a matrix is a system of equations. And how do you solve for two equations and two unknowns? Well, you could use the substitution method. If you can solve for one variable, you can substitute that in another. But matrices, usually what people use are you would multiply your equation. You would multiply a constant by one of your equations and add that to the other one so that some of your terms cancel out. So by putting it into this upper triangular form that you have on the very rightmost matrix, if you had an upper triangular matrix and you wanted to solve for a vector product, the very last row has only one term. So you can actually solve for the last, if you want an upper triangular matrix times x, y, z, well, you know you can solve for z directly. You know that, u22 times z is equal to b sub z. So you could just, that has only one term. You can solve for that one term. Once you have that one term, you can plug that into the middle equation, because you have two terms and two unknowns, but you already have one, you've already solved for z, so now you can solve for y. And then once you have y, you can plug that y and z into the first equation, and then the only unknown you have is x. So you can solve for a system of equations if it's an upper triangular form. So by having a lower triangular and an upper triangular, you can you can solve a system of equations using the upper triangular using what's called back substitution. And then take that result and plug it into the lower triangular using forward substitution. Actually, you have to plug it into the lower. I'll show you why in the code. If we go back to the code, I can show you why I actually have to plug it into the lower triangular matrix first, and then take that result and plug it into the upper triangular matrix. But the other thing, by doing the decomposition, what was that question?
Somebody wanted to know about 22 or 2,000 inversions over what time period by what metric?
Well, I took the matrix of the problem size that we're interested in because, to make it Vive relevant, and I ran it in a loop. I ran it in a loop of 10,000 times, and it ran in about half a second. So that would mean that the matrix inversion step, which is usually the most expensive operation in the common filter, that step in isolation is plenty fast enough, or at least it should be more than fast enough for what we need to be able to use it for. I haven't tried running this on very, very large matrices. I mean, I tried running it on a 50 by 50, and yeah, it looks, if you invert the matrix and multiply the inverse times the original matrix, you get the identity. So, that's a good sign. Another thing about row reduction, if you go into the code.
So I have it right now. I have the inversion function on.
The inversion function.
What did you want?
Yeah. So.
The inversion function?
Well, the if you look at the inversion function, it defines a few matrices there, and then it calls. It has a few steps. It creates an identity matrix, and then it calls LU, and LU is the LU decomposition. So that's the most important one. And that LU decomposition, it's not an LU decomposition of the matrix A. It's an LU decomposition of the matrix A with some of the rows interchanged. And the reason why you want to interchange rows is that if you just do row reduction, the way they taught you in school, you might accidentally have to divide by a very small number. If one of those entries is close to 0 and you try to divide by it, then it could be numerically unstable. So if you swap the order of the rows, you can make sure that you're always dividing by a large number so that you don't have any numerical problems like that. And then what you see is that it does forward substitution into the L matrix, and then it does back substitution into the U matrix, that is the matrix inverse. So it's really really not that hard when you look at it from that high level. But if you look at the LU decomposition code, that's above, and that's a bunch of for loops, and it looks very similar. I've looked at the Fortran code. I can't write in Fortran, but it looks pretty similar to the way people do it, and it looks kind of like a Fortran, especially since it's in a macro. I don't know that you can put comments in macros. I would have loved to put. I usually put comments in my code.
These are getting big enough functions that you really should consider writing them in functions.
Yeah, but I wanted the compiler to have all of the hints that it could possibly have in terms of the way the memory is laid out, so that it can make it really fast.
Okay. You can use the up and down keys if you want.
No, I didn't have a copy of the function in front of me. Give me just a second.
If you wanted to.
Electronics is asking if you're using any special CPU.
Yeah, I'll mention that one. I do intend, at least on x86, to be compiling with -04 and AVX. And even on this old processor right here, it'll still support AVX. So it's going to automatically do a lot of the SIMD. And you say, no, it won't. Compilers are terrible at that. But that's wrong, because I just totally have written a bunch of test programs that do some pretty like screwed up things, and the compiler can still figure it out and still totally parallelize the heck out of it. So I am thoroughly impressed with everything past GCC4. It just figures out this automatic vectorization thing and totally SIMDs it exactly right. Better than I can do it most of the time, and I'm I love assembly.
Well, if
you have a directional talk to it.
Did you guys hear what I said clearly? Oh, no. Okay. Did you guys hear me clear enough, or do I need to go back?
Charles was basically saying that GCC4, if you compile with the -04 flag, should figure out automatic vectorization. And he said he's tested it on some programs that he thought the compiler wouldn't be able to vectorize, and it was able to do so. I haven't seen it personally, but Charles is giving his word that it vectorizes the code. I tried to write the code in a way that the compiler would have as much information as it possibly could to optimize aggressively. But I don't know that it's really necessary. I think the performance is fast enough. Hopefully we can compile it even if the computer doesn't have GCC4, and it would run plenty fast. And if it does have GCC4, then it should run even faster, right? Sometimes you have to. We were looking at.
Real quick. The goal is to eventually actually get it to run on this little guy right here, and he does not have SIMD instructions. Though the ESP32 does have a floating point unit, goal is get it running on there. Eventually, and you'll see why it matters in this case that a regular computer is not in the loop. Someday, hopefully.
Right. So the LU function, there's really two parts to it. There's this giant for loop. I guess it's about here. That's going for every row, and then this first part over here, has to figure out. It's rearranging the rows, because we don't want to divide by a small number. So we find the largest number to divide by, and that's called a pivot table. And that's something that you have to do with LU decomposition to make sure that it's numerically stable. Then this, I don't think I'll even be 5 minutes.
Okay.
And then this part here is actually doing the division. And the thing is that you have to take a row and figure out how much to multiply and add it so that a row below it cancels out to the first term cancels out to 0. That's for the row reduction, and that's how you calculate the upper triangular matrix. But then the lower triangular matrix, right? It has to be, you have to have lower times upper equals A. But what you're actually doing when you do that operation is that you're taking A and you're multiplying A by something. So you're actually you're saying A something times A is equal to U. So you have to if you kind of set up those two equations on a piece of paper, you could figure out, okay, well, there's something slightly different times U is equal to A instead of something times A is equal to U. So it turns out that all you have to do is here set the L for the JI term equal to scale, which is U sub JI divided by U sub II. So I mean, it's not hard. It's just you have to be careful about it. And the other thing, you have to be careful when you swap the orders of the rows and columns in A, that you swap the order of the same rows in L and in U, not just one or the other. Those were a couple snags that I got into, but if I had a matrix package that was working for me on the computer I wanted to use straight out of the box, that could have saved me some time. But I think this was a nice little exercise, and again, it was a step backward, but we're preparing to make the big step forward. So that's all I got.
Any other questions for Dave right now, or? And keep in mind that this is, sorry, any more questions for Dave right now, keep in mind that this is the sort of thing that you'll be able to use on other projects and whatnot, because all of this is going to be licensed under the MIT X11 license.
Yeah, it's 200 lines of code, and it's probably the easiest to install one header file matrix library that you could probably find to copy onto anything.
Okay. Everybody's
If there are bugs, then please fix them and,
Yes.
and commit. But it seems to be working when I've been testing so far. But
Yeah, we have not instituted yet a strict I promise to include patches with all bug reports policy yet, but I hope we don't have to go there. For those who don't know, back in the day, if you used experimental versions of the compiler GCC, you would actually have to pound define a thing where you said, I promise to include patches with all bug reports to fix the bugs that you're reporting. Okay. Back to business. So has anybody in chat yet figured out how to actually get the anybody in chat yet figured out how to get the data for the normals and positions of the photodiodes on the Watchman? And I see that Nerol has reported that it's there, but I just don't know how to get it, because I did try running it against it and it just did not give it to me. I'm looking right now. I guess if we use the Lighthouse console, but we can't do that. This library has to run entirely without that. That's interesting. I never heard of the Mura corrected files. What is that? What is this? To identify the HMD, open the JSON file and get started. User data. Yeah, I don't know what the Mura correction data. What is the Mura correction data? Oh my gosh, what is that? That is a really dense picture. Calibration file. Whoa! I totally do not know what is going on there.
Interesting.
We are going to have to add that to the to-do list to learn about what in the world does that mean. Okay. I have never heard of this. I mean, I've seen the thing in my config, but what is up with the Mura correction stuff? That looks wicked. Oh, it's per pixel brightness calibration. Cool!
Oh.
That's really going to be something that would be a problem for me then, because I wanted to do... I was hoping to do all of the correction for the lens stuff in a vertex shader and do everything in one pass instead of rendering to a texture and then rendering the texture out to the screen. That's really hoping to avoid that, because I am working on the on an Intel integrated graphics.
Wait. So that image is basically a filter that the image going to the Vive is passed through almost?
I think that's what they're saying. So Mike is saying that basically the Mura correction, this thing here is a filter that the Vive, like all the data being passed to the Vive, is passing through before it gets displayed. I don't know if that's actually the case, but that's...
It would make sense, though, considering the way
Yeah.
that the lenses and optics in there, that it would distort the brightness of different segments.
Yeah, that would definitely make sense that that's what's going on. I don't know that that's what's going on, but that I would totally buy it. As a correction for the AMOLED display. I didn't actually realize it was an AMOLED display. I thought it was an LCD display, but it makes sense to use an AMOLED because it's, they're faster and all. Is there really AMOLEDs in there?
I believe so.
I don't actually know where the PNGs are stored, because I do know when I wiped out the configuration on my HMD, it did not wipe out the things.
It says they are.
It says they're stored in the HMD. Maybe I'll figure out a way to extract it sooner or later. Certainly, I did not accidentally blow it away, though. Thank goodness.
Road to VR. Apparently, somebody linked a.
Rob,
about it.
everybody, don't just link articles. Tell us like a brief summary.
I'll look at it.
Okay, Mike's gonna look at that. Okay. So anybody have any idea how to extract, let's see, what are these controllers? There is a JSON file for this other person's controller that looks pretty cool. Yes?
So, Mura correction is that where it basically they.
Do you want to come over here and explain?
Yeah. So thank you, Rob, for the link. I was just reading about it, and it says that basically Mura correction is a system they came up with to level out the inconsistencies in the screen that they're using inside of the Vive, because each pixel would have varying brightness, even just by a little bit, but when it's that close to your face and with the lenses on it, it becomes a pretty drastic difference once you actually level that out and get a consistent image versus one with that variance in it. It helps with both clarity of view and with trying to even out what you're looking at so that you're not drawn to one area over another or distorting the image or the colors. So that's basically all the Mura did, but it was not discussed how Mura correction was achieved, but looking at this, it looks like it's a more hardware oriented. The file is stored on the HMD, so
I know it'd still be software. You'd implement it in software, even though it would be like inside a texture inside the GPU. You just apply in the fragment shader step.
yeah, that's true.
Oh, sorry, I was talking at the side of the mic again. It looks like it would just be something that would be stored in the HMD and would be used by the CPU or by the GPU in the fragment shader step before it outputs the picture to the thingy.
Yeah, it's basically just the last thing that needs to be done to the image so that it can even it out before it gets displayed. And all the rest of the stuff in that article is pre-release or early stuff.
Okay. Brendan, have you been monitoring chat?
Yeah.
Okay, so nothing. Does anybody else have any ideas about how I'm going to go get the data from the controllers, or do you think I just need to plug them in and try to pull it off that way? Because we can't use the Steam tools to pull the data from the various subsystems. I mean, actually, you know what I'll do? I will go run that on the other ones, and we'll just take a look and see what it says. So if I go back over to here, let's close this out.
We can't use the Steam tools because the point is to not use them.
Yeah, we can't use the Steam tools because we have to be able to run independent of the Steam tools. That's like a tongue twister, I guess. So right here I say load config and I pull it from, say, like the headset. If I wanted to say pull it from the watch and 0, I could pass it in a different device ID and then go from there. But that doesn't work. So if I say make, and I power on the Watchman this time, and the other one too, and we try running this, it just doesn't work. Could not get a survive config off of device 2.0. I can look at device 3.0. Could not get it off 3.0. I think I have 4.0 installed. Nope. Just cannot get the data. I've tried a couple of other combinations and there's just no way of getting it off. That is ridiculous. You should just buy a Vive.
How much is it? 800?
Oh, it's 700 now. I think it's 700. So
They wouldn't let them not to.
tell you what, let's take a look at if we just open the one.
So, yeah, basically the biggest thing I've got with the Vive right now is the fact that nobody's willing to, I already said it on here.
Oh.
Nobody's willing to put forth the resources of a AAA game because it's a $700 peripheral, basically.
Yeah.
The market share just isn't there yet for the resources of a AAA game. And a lot of people are waiting for Vive 2.0. They're like, it's there. My cell phone gets replaced every year. Where's the new Vive?
Why have I forgotten? Is it in here? Oh, whoops.
There's
Are you colleagues and live together?
Some of us live in the house together. Adam and Brendan live here. And Mike and Dave do not currently live here. Florian, we do not currently have access to a good 3D printer. We have friends who have access to okay 3D printers. But,
I have sort of decent ones.
Oh, Mike says he has a sort of decent 3D printer. So at any rate, survive, get, config. That's defined here, I think. Yes. And so I say hid get feature report timeout, and I pass in the iFace and then devno. Devno comes from like CTX dev. So that would be see, where are those set up? Okay, so I guess that would actually be interface 0. Let's see, what would that be? If it gets it from 1, so that can't be right. udev dev hmd. That's 0. So Watchman 1 and Watchman 2 are 2 and 3. What in the world? Why is it getting it from the IF Lighthouse interface? Dev Lighthouse. That's just weird. Huh. So it is actually 2. So 2 is where it should be reading it from. So if I try reading it directly from the Watchman, nothing happens. Just nothing. So let's see here.
It's a new one. The name.
oh yeah. He gets it.
It's going to open that device, that context. Yeah, it just can't get the config. I guess I could add something to be able to pull it from the... yeah, I don't know. Why wouldn't it be able to pull that way, though? Maybe it's hiding on the... If anybody has any ideas here, I'd be really, really grateful. I'm just shooting in the dark. I'm just going to try to pull from all the things. Except for 0, because I already know that one works. Oh.
Are you seeing? Oh. Rob suggested treating the pixels as signed and subtract 128. The pixels are mostly gray because it's a median.
Man, why did we have to pull up the Mura stuff? I can't have you guys distracted with that. we gotta figure out how to get the Watchman data. So the other reason I want to get the Watchman data is because I think if we place 2 of these in 2 places in the room, we'll be able to try to narrow down where the lighthouses are by trying to solve a simultaneous system of equations to determine, like, is that and that really a valid place for those 2 lighthouses? Where would they probably be if the 2 were to match up to the controllers? Yep, looks like none of the devices from 1 to 100 show anything.
They were asking about what the actual distance between your lighthouses was. Oh, there it is. I'll see if I can measure it.
I mean, if it's been 3 meters to the headset diagonally, then it can't be more than 6 meters apart, which is the 18 feet
Hey!
that's moving up.
Interesting. Too much data on packet from config device 0256.
They're almost exactly 16 feet.
But I mean, they're working fine,
Yeah.
so.
Measuring tape killed the sound.
Actually, guys, if you want, we can try this microphone for a bit. How do you like this one? See if this one works any better. It's actually in the webcam.
Popcorn.
This is relevant to answers.
Yes.
Too much data on packet from config for device 00. Let's see, what is it saying?
Okay. Sound is good.
Sound is great with me, Mike. So then there's stuff that might be. Jason isn't really sticking to the popcorn very well.
135. Is that valid?
Wow.
Good.
That might be valid.
Interesting flavor. I don't like that.
So 135. What happens if I just make this bigger? Can we actually read that? Let's see what the data coming back from the device is. That's something. That's definitely something. But that does not look like configuration data. That looks much more like settings data. Huh. Not sure what's going on there. Yeah, I don't think there's anywhere else I can load config data from. I'm not sure what's up with. Oh, hey.
Bacon caramel popcorn.
How much of this did you make?
A lot. That's about half of it right there.
Internet.
A pound of bacon.
Do you want this wonderful bacon caramel popcorn?
It's amazing.
You can't have it.
You just totally blew somebody's mind. They're like, bacon popcorn, what?
Now I use maple syrup instead of corn syrup in the making of the caramel.
Did you guys hear Adam when he said that?
I knew I smelled maple, but I wasn't sure
About the maple syrup?
why.
It's also maple smoked bacon, so I don't know what difference that's going to make.
No, I think it was just the syrup smell. It's got a very powerful smell.
Adam apparently used maple syrup instead of corn syrup on this batch to make the caramel.
Yeah, I like that a lot.
It does make a difference.
I've done a variation of this where it's got pepper in it too, and that has a very interesting kick. I like that a lot. Some people didn't know. Tomorrow I'm going to try to do caramel apple with apple bits in it. I don't know how that's going to work.
You need skills.
We have some people coming out of the woodwork because bacon popcorn was mentioned.
Yeah. Suddenly something that makes sense to everyone was brought up.
I'm thinking I'm not getting any kind of configuration from device 0. I guess for the time being, we can just use the configuration data that was provided by Nerol. I wish Nerol had stuck around. I'm sure he'd be extremely helpful right now. So the other thing I wanted to touch on was we do need a better disambiguator. Wait, when do you think you'll have the other live streams up on your channel? No, all the other live streams are currently live. This is the only one, and this one's going to become live by tomorrow morning.
It takes a while for it to render long ones.
Yeah. I'm not exactly sure. I know device 0 is the one that I send the magic codes to, but it's sending me this thing here, which to me looks a lot like those magic codes that I had been sending to it, like turn on codes. So I'm not really sure what's up with that. Let's see, magic, is that in here? No, that's in USB. Magic? Yeah. So 0, 1, 80. So it's 78. No, it's 87, not 78. Actually, that's interesting. Does anybody know if 8729 are valid gzip headers? Actually, now I'm curious. Can I just read it all in one fell swoop? I mean, it doesn't look like gzip data.
Apparently they're saying that the archive of your previous streams was not available. I'm gonna check.
Archive of my previous streams are definitely available. Oh, wait, hey, internal trivia or infinity trivia. If you can, please try to get some of the packet dumps of somebody pulling the configuration data from the Watchman controller.
Is this part 3 or part 4?
This is kind of part 4. There is no part 3.
Okay.
Part 1 was like actually 2 live streams. This is part of part 2. Part 2 is where we try to find the location of the lighthouses.
Yeah, because I can see the 2 videos a week ago and 5 days ago.
Yeah, I'm thinking it's probably not gzip as well. But it doesn't actually look as much like the default data or the whatever it is, the setting data that I thought it would. No, it's part 2, episode 2. Yeah, FFFF does not seem like something that should exist in a zip, but what could this data be? I'm really curious now. I wonder if it's possible to get more data at once from the HID reports.
There are 66 people watching this and 300 watching Kitten Academy.
Voxeltastic runs tons better in Firefox than Chrome, right?
It's funny. Sometimes Voxeltastic will run better in Chrome, sometimes better in Firefox. I've never figured out why.
Jamie is asking if there's a not browser version.
No, there is no non-browser version of Voxeltastic. Voxeltastic is based off of the render engine from No Euclid, which is not a browser thing, and it said it's only on regular computer. If you guys haven't seen No Euclid, it's totally worth looking up, I think, because I think it's pretty cool, but I made it, so I'm really biased on that.
You think a lot of things are really cool.
I think a lot of things are really cool even when I don't make them, but, you know, when I do make them, I wouldn't do it if I didn't think it was cool. So I guess I could have a larger control message. Okay.
Also, we're coming up on 1 here soon.
Yeah, I know. I'm going to cut it off at about 4 hours and just a hair over. Because we didn't actually start recording until about maybe 10 minutes in. Let's make the buffer bigger and see what happens if I just read it. The control message sent back 128 bytes. That's interesting.
What did it send before?
64, because I thought that was the biggest you're allowed to make them.
Interesting.
was their character data in that, so.
I'll print out the character data. Let me just try making sure there's nothing good at the end of this. Oh, that's weird. I read it again and it's...
Different.
Yeah. So apparently you're not allowed to make it bigger than 128, otherwise it just gets hosed.
It freaked out.
Yeah, I was pretty freaked out. No, none of this looks like character data. Yeah, it says the same thing the first time and the second, so... Yeah, I don't think this is configuration data. If anybody wouldn't mind getting some PCAP dumps of reading this data from a actual Vive on a Windows box, that would be pretty cool. Trying to understand what message I would have to send it, or even if you just take the PCAP and then send me a copy of the PCAP, that way we can see how they actually pull the data off.
You know I have a live setup for it over at school, right?
What?
You can just ask and I can send it to you.
What do you mean?
I have a Vive setup that's UMBC.
Okay, so you'll do that later? Okay.
Yao asks which engine it is.
Which engine?
Big or little.
Oh, most of it's little endian. But none of this looks like actual data, so. I mean, FFFFFFFFFF looks like this might have like Macs in it or something, Mac addresses or something. But
Nyrol posted a bunch of PCAP files, and Infinite Rival said they posted PCAP links in chat.
Yes. Oh, Infinite Trivial is Nyrol, by the way,
Oh,
in the chat.
well, somebody said Nyrol, and then
And then
Nyrol
Nyrol was like,
piped
hey,
up.
oh yeah, oh cool. Hey, thanks, Nyrol. You're gonna have to start piping up in chat so we know that you're working on things.
I think he has, but
Oh,
He
that's...
said he linked it in chat.
wait a minute. Herp derp, Infinite Trivial is Nyrol.
Yes.
Yes, we just went through that.
Okay, I did not catch that until right now. Wait, you linked it in chat. Did you also post it in the issue? Because I can see the issues. I can't see chat on my laptop.
Chat's kind of a beast to sort through, too.
Say it again? Oh, no, I'm pretty quick with Wireshark. I'd love to be able to do that right now. If you have the PCAPs, I can do that right now on air. Yeah, Nyrol, or Infinite Trivial. Where is the...
He just linked it.
Don't link in chat! I can't read it if it's in chat. I can only read it if it's in the issue in GitHub. Sorry, I didn't mean to get angry. Oh wait, the microphone's here now. It's not here, but...
That is not what I thought.
Nyrol, can you, I'm sorry, I didn't mean to get angry. Everything you're doing is so helpful. Thank you so much. Yay! Thank you! Which number do you think would be the most likely to contain this one maybe? Turning the wireless controllers on first. Do you think that's where it would be?
Which message do you want?
I'm specifically after the messages that would pull the configuration data from the Watchman controllers. So probably, I'm guessing.
Likely either starting SteamVR or plugging in the link box.
But if it lives on the controllers, then how would that be possible?
Oh wait, it lives on the actual controllers themselves. Then yeah, probably starting with controllers.
Um,
Now that you mention it, they do take a little bit once you turn them on to actually sync up.
And use USB.address that contains 1.11 as a filter.
One point one point one.
1.11.
Oh, really? No, nothing. Not 1.1.1 either.
Charles is not using a mouse.
He's totally using a mouse. We spent 15 minutes fixing the mouse at the beginning of the stream.
Well, no,
Better
that's
be using-
an actual mouse.
No, Charles doesn't believe
No,
in actual.
like-
I don't believe in actual mice. I mean, I use them sometimes, but only, whenever. I believe that touchpads are a completely cromulent mechanism for getting human input into a computer.
I like my touch screen, thanks.
Get out.
No, really, I thought it was going to be silly at first, but I absolutely love having a Surface.
I want one. One of the new ones.
Okay, here's a bunch of USB controlled
The Surface Pro. With the keyboard.
FF83. That's out though. That's set configuration. See here.
Yes, with that interesting articulated
Yes.
thing. I specifically want the one with the video card. It's like
That's
$3,000.
That's this one.
Nice.
It was, well, it's 22, I think. But
Oh,
yeah.
yeah.
This is the i7.
Oh, that's interesting. So it looks like what's going on is it's sending something that tells it, "Dear Watchdog or Watchman, please send me your configuration," and then it keeps polling it.
Enough for what I need.
I think that's what's going on, unless this is to a different device altogether.
It's so fast.
Let's make sure. 190.
What's the battery life?
No, it's definitely the right device.
With the keyboard on forever. I've never had to worry about it.
But I don't see anything being returned.
I mean, if I'm sitting there like gaming on it, then less.
Whoa, hello, data.
Full when I came here, and I've been using my battery since before the stream started, and I'm only at 30%. It says 2 hours left. So 6 hours of constant use.
789C. Now that looks like some magic.
I have no idea what battery was at.
That looks exactly like the kind of magic I'm after.
Yeah, I want one.
I believe 789C is a valid gzip thing.
And now he invited in all of the touchpad hate.
Oh, it's not gzip. What is the online gzip calculator, I guess I would say.
190 and 111.0 are the two wireless receivers.
Deflate. Aha!
Deflate. CCAT.
789C. Ah, that's some configuration you got there in that awesome PCAP dump.
This chair was way lower than I expected.
Oh,
I guess that was a little loud. Sorry about that.
kind of surprises.
But something happened in order to get that. What did they do to request it? So it starts there. So what did they say 1.11.0 was? Brendan?
190 and 111.0 are the two wireless receivers. Said Nyrol.
Okay.
Real.
Nyrol, when you say the wireless controller, so like the packet that's going to the controller here, is that like the actual same device that I would be talking to when I'm like getting the light data to and from the device?
comment from Mark that's on screen.
Oh yeah, no, I know. I'm going to do that in a minute. But I just wanted to make sure I'm actually looking at the right thing and that I can actually talk to this and I don't have to do something wacky to get it to start talking to some other way.
As if we haven't done anything wacky already.
We have done nothing wacky. Did you see that Nyrol said yes?
That's awesome. Thank you, Nyrol.
I do not know enough about USB protocols to not be totally confused by this.
Okay, so just so everybody online sees, I see a 789C in this USB control packet. And what happens with USB control packets is it's a really simple command. You send the control packet, and then it sends you data back. But specifically, I've been looking for something that has 789C in the second bytes because I know that Valve compresses with gzip. They take the config data, compress it down, and then put that on the controller or on the device, and that's the compressed configuration data. So because I see this 789C, I know that somewhere around here they're sending it some magic dust that makes it go and give me the data.
How the heck did you figure out that 789C was their compressed data?
Oh, okay, so the way I do that, so for instance, what I just did here was I took data, I just said test, and I compressed it using the deflate algorithm, and so this thing just returns it in base 64. If I debase 64ize it and dump it through hex dump, it starts with 789C, which is the magic that says it's a deflate compressed file and something about the way it's decompressed, and that's what the 9C is, but I don't really know what that magic is.
That is some magic juju I've never seen before, and I like it.
So
I think I've learned more in the last 3 hours than I have this entire semester.
that's depressing.
Isn't that what school is good for, is not teaching you things?
Okay, so the conversation with 111.0 starts here. Control in.
3-minute warning.
No, it's not really 3 minutes. It's a soft 4 hours, but and we did start 15 minutes in. Let's make it our mission to try to get this this data off this device here in the last 15 minutes, though. Conversation with 111.0 started here. Sending the control message in. Whatever, it's just getting some data. I don't really care what it does. Control out with an herb setup. Okay, so it's saying request length 64. W value 3FF. I don't know what that is. Maybe there's another way of getting the data from the device that I'm unaware of. FF8300B6. That looks like trash to me. Oh wait, no, it's not trash. That's us sending the Watchman. So that's some sort of magic code that gets sent to the Watchman.
Magic code.
Yeah, I don't know what it is. I don't know. Don't care, but I guess that means I should probably be sending it. But then it looks like if I start issuing... this message here, just a request for in, and I just keep requesting it, eventually the Watchman responds much later. Oh, here it is. Here's some data. Eventually it responds with the actual compression stuff. Scroll down too far. Oh, that's weird. It sends this data first. Oh, weird. Okay, wait, so 310. Let's see, what does the actual control message look like? So right here, get feature report. I'm issuing a live USB control transfer with transfer in, so it means I'm requesting data from the device. This is how I get the config from the main thing, and it's using 0x300 or data 1 or data 0. So it's request 1 310 W index of 0. I guess that's the interface number. Let's see, I guess that gets passed here, so that's interface. Do device interface. But data 0 has to be 10. Let's see what it is for this one. 11. Okay, what about this one? 11. Okay, so I guess if 10 starts it off, if I read 11 a whole bunch, so there, AA10. So that should be responding. Maybe I have to issue this several times to get a response. Okay, Watchman 00, so that's right. Tag 0, issue 0. Let's try running it again and see what I see. No, what am I doing wrong? Why is that not?
You have IRC.
Maybe I have to issue the other command first before it'll start talking in any reasonable sense. So I'm sending B request 1, W value 310, and W index 0000. But I am getting data back. Why am I getting data back? Oh, I gotta turn that down from 128.
I make core balances.
Okay, so 64. It says 64 bytes back. Why is what I'm getting from the watchdog? Oh. Getting negative, although to be fair, the Watchmen are powered off. Let's power them on. Hey, Gnarl, do you think that it's, I guess you would think that they are stored in the, they're stored in the Watchmen, right? Not in the other thing. Oh, wait, Charles is doing, wait, what?
You just now noticed that.
Noticed what?
Look at the very top of the chat and you'll see. You were asked if you work on IRC. We answered that. But
What does Charles know about USB?
No, above that. What I said.
Charles is doing Charles on his code, and he won't respond to anything we don't shout at the back of his head. Yes, correct.
that was easily 5 minutes ago. What I was going to say is, who watches the Watchmen?
I'm gonna install USB Mon on my computer and see what this message is going out at. So I'm sending a control transfer. Beam request type is A1, request 1, W value 310, 0x00.
Wow.
Device is responding with nothing. Nothing at all. So what makes it so different when they ask for it?
This is almost exactly what I was trying to do the other day, except you actually know what you're doing.
So here, the Steam stuff is connecting and it's issuing this command. Oh, maybe we need to send the Watchman a command in order to get the Watchman to start responding to this stuff. Okay. Load config. I'm gonna make another parameter that has an extra magic flag.
I don't think there are any other modes.
yeah, I don't either. But I'm not the expert.
Were the controllers officially called Watchmen?
I don't know.
Why
That's
are
just
you
the
saying
reference.
Watchmen, then?
That's the reference I've seen everywhere. Just a lot of people refer to them as Watchmen.
Okay. I know the lighthouses are called lighthouses, but that's just in the official documentation what they call them.
So now in here, I have send extra magic. So if it's a Watchman, we might need to send these extra messages that are being sent by Steam. So they start here. So the first one starts with request 1 301 W index 0. So that's 01.
Oh. There we go. Watchman is the name of any Lighthouse receiver, including the HMD and the controller.
Then why in the world do they specifically call the others Watchmen?
there's probably a lot more going on in the HMD. The controllers, the Watchman is probably the only thing they're concerned with at the time.
Okay, so let's run this. Threat from first, 64. Ooh, that looks interesting. Let's look at the data. You need to, like, cough or something?
Terrible allergies. Sorry.
Okay. Let's get rid of this stupid %C thing. So the first one's tagged 01, 03, 02. That looks like some interesting data. And that's definitely different data than... Oh, no, that's right. That's good. That's really good. That's perfect. Guess what? The stuff coming back from the valves, 01, 03, 02. So that means that I successfully finally was able to talk to one of the watchmen and say something. I think. Let me make sure that I'm talking to the right device. Yep, I'm talking to device number 2. So I can talk to the watchman a little bit. Okay, let's see what the next thing that has to get done is. So after that, Valve sends a message out. Request 9.3FF. Wonder if that puts it into some sort of like read mode. I'll just try skipping that step because that makes me nervous. The next one is a control in. That makes me less nervous. By the way, the way I blew away the configuration of the headset was when I sent a control out when I should have sent a control in. So it just deleted the whole configuration file.
So I'm guessing you're going to be more careful about doing that.
Yeah, I'm going to avoid those messages as best. Yeah. So let's just try this one. So without sending the control message, let's see if it talkies.
Well, it shouldn't be too bad though, because I mean, can't you just go and reset the firmware on those?
No, you can't.
I take it you discovered this the hard way.
So it returns FF. Oh, bums. So their thing, when they run it, it returns something meaningful. When I run it, it returns just a bunch of zeros. Yes, it returns a bunch of zeros for me. I might need to send a control message. That makes me so stupid nervous. Is anybody else in chat more familiar with the way the HID requests work? That they would be able to look at this packet and tell me what it really is doing, so I don't have to worry about damaging my Watchman? Also, I want to see real quick if they send something else to say leave the mode. They don't. Maybe here? Nothing. That makes me so nervous. I don't want to do it. Let's see, what is the magic? What does some of that look like? No, it doesn't quite look like that either. Okay, tell you what, guys, I'm gonna go turn this off now. And what I'm gonna do is I'm gonna get Adam to back up the configuration on these Watchmen so we don't accidentally blow it away. And then what I'm gonna do is I'm gonna basically just use exactly the same messages that Valve used in order to, send the thing to the Watchmen and pull it back off. And I guess you'll just have to see in the summary video that'll be coming out sometime later this week. Wait.
In the next few days.
Alan. It'll be quite noticeable if you know what to look for. Alan, I can see in these Wireshark dumps you're sending a control message out, and then when you send this other control message in, the Valve thing totally, or sorry, not the Valve thing, the Watchman totally gives you data back. When I run it, however, the Watchman does not give me data back. Instead of FF whatever, it sends FF. You get FF83, I get FF00. Now, actually, if you think you might be able to just get me the configs for these, and I don't have to go over and back them up, I might be willing to just give this a shot right now. I'm just so nervous to accidentally blow it away. Oh, Alan, what I'm trying to do is get the configuration off the Watchman. If I treat the Watchman like the HMD, it just doesn't send anything at all from the configuration data. It just nothing. And what it's looking like is that in the actual thing that you're doing, you're sending the so you're doing the same sort of thing. So like in order to get the config, like I will send a not 305.
Stare at your chat.
Chat. What? No, I know I can use Lighthouse console to get the configs, but I have to go over to Adam's room, do all that stuff to back everything up before I can start pulling the config here in this code. I have to be able to make this code pull the configs itself. So, okay. Yeah, okay, fine, Alan, I'll go do that. Actually, Adam! If I plug the Vive in out here, can you execute a command at the Lighthouse console? I'll email it to you, or actually, email is a bit of a pain with the way I have it all set up. Can one of you guys email him? The link is in issue number 5. Okay. Go to issue number 5 on Live Survive and pull out the.
I don't have any of that open.
Adam, can you open up just github.com/cnlore/livesurvive? Okay, I guess we'll go do all this right now. No, I've learned. That's why we're going to be backing up the configuration. Let's go unplug everything and be boring. Say what? I think... sorry. Look up issue number 5.
Issue number 5.
And somebody posted a link to the narrow Lighthouse redox thing, and from there you can get all that. Oh, so internet, you might think this is entertaining. I don't have access to a computer that's fast enough, but Adam in the room back over there does. So we actually, let's see if I can, oh! As you can see right there in the very center, there's a cable coming out of my attic that goes down to Adam's computer so that we can actually get the data, get the USB and everything from his room out here. So I'm going to go plug this into the USB extension up there so that Adam can pull off the config so we don't accidentally blow it all away. So that right there is now going to Adam's room, and I'm going to try to get Adam to back up the config file so we don't have to totally blow that away again and go through another couple hours of misery.
What is this? Is the USB extension?
Yeah, a long ass active USB extender, and
Wow.
even well, just as long HDMI.
Wow.
So that's odd. It doesn't list the lighthouses in there. It's a different LHC number. It's oh, I guess it doesn't say on the box, does it? Yeah, those serial numbers are different than the serial numbers in the. Can you So I'm going to open up the configuration file for my headset and find out, hopefully in there it'll list what the LHR numbers are. Bummer. I guess I didn't post the actual file. I'm gonna have to get Adam to open the file and look at it. Hey Adam, open up the email. I'll make sure that the watchdogs, watchmen are powered on. Open it.
Hey, Charles.
Sure.
I'm gonna hit play an ad.
You're what?
Hit play an ad.
Play an ad.
Okay, you're not doing anything right now, so.
Oh yeah, hit play an ad. So
There's
we're right
something
now.
ads, warning, danger, something
Where is
in the YouTube.
Yeah.
I don't know if it shows you that it is playing that, so.
No, it
Oh, you know what? Let me plug you into.
No, there's definitely something wrong.
It says
I have not
play
plugged you into video yet.
That would.
Okay.
How about power?
Power's plugged in. Video is not plugged in. Give it a shot. Yeah.
You know, almost anywhere else, this would surprise me, but not here.
What?
Now it's working, but it's because the headset's connected to not tracking. Okay, that's fine. Okay, good. Open up the configuration for it. Perfect. Oh, hey.
I need help. Okay. So I can't figure out how to back this up right now. Let's see. He's saying that, sorry, Nirol, if you're here, that would be really helpful. Oh yeah. Does anyone know how to get the LHR number for the controllers? Because it's just not showing up in the Lighthouse console. Oh, let's try serial. Hey, Adam. Close Lighthouse console. We're going to run it on the folder. No, it did not show it. When we run a Lighthouse serial, when we run a Lighthouse console serial, it only shows it for the HMD, not for the these guys. Despite these guys actually being hooked up and like green, so not sure what's going on there. Look at the USB descriptors. No, I mean, I want to use the Lighthouse thing from Valve to back up the configuration that's already on these guys so that nothing goes like bonkers when I go send it some commands that I think I need to send it to get the configuration stuff.
And hopefully not nuke everything else in the
Yeah, I don't want to nuke it. No, I did. We did Lighthouse console space serial, and it only shows the HMD number, or sorry, the LHR numbers for the HMD, and not for the Watchmen, which is really confusing because it does show up in Steam. I'm not sure what's up with that. But what is LSUSB going to tell me? It's just going to tell me the descriptor numbers, not anything I can back up the configuration on the Watchmen with. Oh, that's a reasonable point. I guess I could plug these straight into Adam's computer. Let's.
Out in a few minutes. It's getting really late.
Yeah. Does that mean I do need to plug it in to get it to talk?
Disembodied human arm. We'll never see that until he goes to edit the video.
What?
This is so good. Read Azrael's comment.
That's right. Someone from Valve just today watching this giggling. Indeed.
The person that said indeed is him.
Yes, I know.
Yeah.
VK Tuesday invented. Wow. You can be anyone on the internet. But he is.
looks like the config files have been rescued.
Excellent.
Okay. Well,
Do you want to say goodbye to everyone? Oh, I meant like Dave, because he's about to head out.
All right. Well, have fun with the backing up of the data. I'm gonna.
We just did.
Gonna well, you already had fun with that.
We just got the
So,
data, the configuration files backed up.
I've been up since 6 in the morning, so I think I'm gonna head out. But
Ooh.
it was a lot of fun.
Okay. Thank you for coming, Dave. And
Thanks.
hopefully we'll get to the point where we can start using your stuff soon.
Yeah. Well, hopefully that stuff will be ready soon.
Brendan, Adam just emailed you a copy of the configs. Can you commit the? Can you open it or put them in the issue number 5?
Paste or
Paste into issue number 5, or like
Do I
not
have to
paste,
be,
but like
logged into GitHub.
yeah, you'll have to log into GitHub.
Oh dear, I don't even remember my password. And apparently it's a token now, or something.
Goodbye, Dave.
Bye.
See ya.
Look at him leaving. It's so sad. Brendan's still here though. Okay. We got the configs backed up, so all is well now. Anyway, now I can go send these things data, and I don't have to worry about really terrible things happening. At least I don't think I do. So let's get cracking. So it looks like they send this message, which is W value 3FF. Let's see what we normally do. Update feature report. Normally we send not that. So it's at least 09 code. Yes, B request 9, 3FF. So we should be able to use update feature report, this function here, to go send that value.
I can't believe this thing is still running. And I worked down the whole time. Wow.
Bye, Dave.
Bye.
Let's control out.
One thing I will say is this has some huge feedback in your life.
Thunk. Thunk, thunk, chunk.
P request 9, W length 64. What am I missing? Guess we should take a look at the data. Though that's coming back. I don't understand how that works. Sure, whatever. I will. How does that work? It says it's going from host to there, from host to there. Nyrol, are you still? Wait, did anyone get to somewhere on the pose solution problem yet? Oh, sorry. Whoa, I'm back in. When do you guys get back in chat and see what's happened earlier?
I mean,
VK2Z's been saying things. We were finding the position of the oh, you know what, actually I'll show you that part. What you missed a little bit earlier was we're using this point cloud to approximate the positions of where it thinks the camera might be. This is pretty terrible the way that this one was configured, but we do have other ones that when we ran them it produced some pretty good results. I can show you some of them. I think that I still have some of those files around. Under Combiner. Whoopsies, that's wrong.
I just tried to disconnect.
Say what?
The controller just turned off.
Yeah, that's fine. Okay, so here, this was also, I guess, a bad data set, but some of them, they get pretty good. This is the point cloud probabilities of the thing being at any one location. So this is, in case you wanted to see that specifically to Alan, that's kind of the recap there. We can change that so it's a little bit more restrictive. So here you can see that, like, chances are it's probably somewhere here and probably somewhere here. The one thing I thought that was really unusual was that I was able to approximate the distance really well, and like we measured it with a tape measure and it was accurate within like 2-3 centimeters, but the actual like up-down position of the what do you call them was not quite as good. The lighthouse was not quite as good. Two places at once. We used 2 lighthouses at once, if that's what you're asking. We're trying to find the location of both lighthouses. Yeah, Nerol, if you're still in here, I really don't. I want to know, do I need to send this data or do I need to just send the really short thing? Because I don't necessarily know. Oh, whatever. I'll just send the short thing and we'll see what happens. Oh, you know what? I need to plug the thing back in. Everything was static, no motion at all. There is somebody else who wanted it with motion. I don't remember who it was. Somebody in the issue wanted me to collect some data with it in motion, so I did take that. And I do understand now that there's no way with just the headset alone for you to determine the exact location of the lighthouses. It takes additional data because there's just really no way to resolve the shell down to an area that's much smaller than maybe a decimeter and a half. Because you already get to the point where it's like so precisely, like it's right there, but like moving the camera a little bit would produce like micrometers of difference on the effective position of the sensors. Oh man, Alan, I think if you do get a chance, you should probably just rewatch just the first part of this live stream because just the very first bit, it kind of goes into all of that status. Okay. Let us try this again.
Yeah, we're about to hit 5 hours. Did we record the cursor part?
Yes. Well, we didn't.
I know, I think we did record. That was while we were recording.
Yeah.
We recorded part of it.
Oh yeah, okay, Alan, you might not want to watch the very first few minutes.
We started, then we stopped, then we started again, and then he came out with a solution, which took another 5 minutes to implement. What is the end goal of this? They want to know why.
Nope, they won't know why. Sorry.
not sure exactly what he was talking about, but VK said he was going to go check something out.
Probably this video. The beginning of.
Bomber. So what do I actually have to send this to tell it to give me the configuration? I was trying to figure out how to find lighthouses. Right now I'm just trying to figure out how to get the watchmen to tell me their config files. Nothing though. I'm really confused by this one thing though. If anybody is particularly used to USB, I've never seen anything where, well, FF. Okay, I'll buy that. Oh, that's me. So no, I don't understand how that works. It's like sending a message that's empty, but then it's getting data back on a control out message. I've never seen that. I don't understand how that works.
Can you Wireshark a USB connection?
Yes, in fact, I am Wiresharking this USB connection. That is how I'm looking at what I'm doing right here in the code.
I guess technically it's part of, but not the exact same. It's not Wireshark itself, so...
No, it's Wireshark. It's using USB PCAP or USB Mon or one of them, but Wireshark totally understands exactly what you're talking about.
Though I wouldn't recommend.
So I send a control out. See what and compare the official Valve thing to mine. So beam request is 21, request is 9, value 3FF 0064. Okay, I guess I'll send one of 64 length. Return 64, so let's see what that looks like. (21.9) 3FF 0064, but then it sends the data fragment immediately, versus in his stuff, it sends that later. Why would his message have that later? Oh, whatever, I'll just copy it. Are you guys in chat?
Everyone's talking about what VR capable really means because I mentioned you want to point at the box and laugh.
Maybe this whole project is actually about porting Virtual Boy to Vive. I've got a Virtual Boy if you want one.
Okay, I'm sending seriously the same thing right now. Why is this not working?
Because it hates you. Obviously you have angered the gods tonight.
Fault 2. That's weird. Oh, wait, no, now it's fine. No. No, it is. It's getting fault -9. That's really confusing. That's also confusing because as soon as I send it that message, the Watchman just turns off.
It's the code for nap time.
So clearly that's not what it wants to talk about. Even when I send it blank, it wants... Wow, what in the world? Stop turning off. I don't get it. I think I'm sending the same message. Or something.
Stop insulting the Vive's mother.
Wait, did I ever insult Alan? Other than that one day that I didn't know it was Alan?
I don't know what you're saying over USB, but you probably insulted its mother.
Oh.
It's giving you the silent treatment. Except for when it bedings to turn off.
Yep. It's like, I don't want to talk to you no more.
If I send it anything, it's like, I don't know, sends me a -9 and then turns off. Look, it just turned off. I'm not... Why is the thing just turning off? Let's see what happens if I do this. Does it still turn off? I'm not even... It still turns off. Get feature report. Okay. Are you just not allowed to read the configuration when it's wirelessly connected? That doesn't make any sense.
So he was saying something about what is the actual process for binding a controller to an HMD?
I don't know, actually.
So they come pre-paired, right? When you set it up.
Do they? I don't know if they come prepared.
Yeah, you don't have to plug it into USB or anything. As soon as you turn them on when it comes, they automatically know to hook up to the box. Or the HMD, whatever. The only time I've ever had to plug mine into USB were to update the firmware.
That makes sense. Okay, so that matches perfectly. But then there's this magical control out message, which makes the controller your friend. I do not know how this works. I have never, ever seen an out USB control message that will accept data back.
And now you've found where the magic happens.
I wonder if the controller keeps turning off even if I don't send it that message that causes it to freak out. Looks like it stays on.
Try sending it a different message.
I've been poking at that. But it does actually return an error code. URB status, broken pipe. Let's just compare these two. (21.9 3FF 064). Why? Then if I send a control message, it just dumps the whole thing. And returns an e-pipe error. Okay, what time is it here? It is, yeah, 02:03. I think I'm going to give up for tonight until I can figure out how to read the configuration data off of the Watchman. Unless somebody online is willing to go give that a shot. Then the next couple steps are going to be to just lay the Watchman down on the floor with the HMD in the middle and try to resolve a little bit better the locations of the lighthouses from that. I was hoping that that would not be the case. Does anybody else have any major points or anything they'd like to talk about before closing up shop?
I'll never sleep because of you.
Yeah, I think it's time to call it quits tonight.
And apparently there's still a bug existing.
Checked it, and a half float bug is still in the V6 Extreme. I don't think I'm going to do it next weekend, but I'm hoping that you guys can start doing more work with the. And VK2Z, you're talking about making sure Nerol emails you. Nerol, if you have, I really want to understand. So, what is going on? Can you just stick around for a minute just to help me out here? Because I have never seen a URB control message that accepts data back from the device, USB out URB control message that accepts data from the device. And that's what I'm seeing here, where I think you're sending it 21.9 3FF size 64, but you're not sending it any data. And all that's happening is we're getting data back from the device. Seriously, like, does anybody have any idea what's going on with that? Because I have no idea. I have never seen anything like that. Nothing? Near all? Anyone?
Keep in mind it takes like 10 seconds for him to hear that.
He says no
Oh.
idea Leslie.
Oh, I have never seen a message like this.
You're out of his area. That's
Oh.
what he's...
I have no idea why. I'll just have to play with it more offline, I guess. Well, thank you everybody for coming out today. I'm gonna close this down and then upload, and it'll probably be ready midday tomorrow for watching the whole stream. Alan, if you're interested, I think the pictures that we made with the 3D thing were kind of neat earlier on. Other than that, not really much else. I'm gonna go plug this back up in a couple minutes and make sure we didn't just totally blow away the Watchmen or something, but it's still linked in green, so it can't be that bad.
More streaming.
Oh hey, no, Nearall, we got like all the wireless packet stuff decoded. That's all fine. I just want to get a copy of the config off is all I'm after. Yeah, what is going on? How in the world do you have a control message that I just don't know? Okay, sorry for this being another anticlimactic closing to another great deal of effort Vive thing.
This is hacking. This is what you should expect by now.
Disappointment in the tears of those who are attempting to do anything with forward progress. Got it. Okay, so you just don't want to mess with anything in the Wi-Fi thing. Okay. Well, thank you everyone for coming out. Bye. I do have to let it run for like another 10 seconds to clear out the buffer.
Yay.
Bye, everyone. Michael and Brendan say bye.
Later.